Welcome. I'm glad to welcome you to our session in the name of Adastra and of course also Microsoft. Let me introduce myself. I'm Jakub Martin and I will do or guide you through the opening, and during the day I will have some themes also to explain to you. Today, what we are presenting to you are the tools and technologies which are narrow connecting and with data processing and which are available in the cloud. And these technologies you can name also as a buzzword because these technologies have to do something with the data science. The schedule of the session you can see here. There are two blocks, basically. The first one, the morning one, is much more theoretical and for the architecture point of view. So we will present you all the technologies from the architectural point of view and what they are used for. And in the afternoon, you will see some practical session, how actually to get to Synapse, how to actually build a Power BI, how to build this. But I want to actually add one warning, yeah, or all these sessions are really brief and we do not have enough space actually to describe everything. So if you want really deep dive into some of the technologies, you have to do other session. This is just really the opening word for these programs. So let's start. In this session, we will like you to introduce you and explain you how the data and analytics are transforming the business and how actually the next generation of the technology can help in such a transformation. In this section, we would like to actually advocate the usage of data warehouse itself. As you know, Adastra is in the field of data warehousing and data processing very experienced. And even after 32 years, where actually data warehouse is in the center of decision making of every firm, it is still there and will be there for the future. But with the new technologies, with the cloud technologies, they are opening new possible cases and new possible benefits which you can obtain from let's say, basically in general data transformation, but of usage the data warehouse. What will I stress firstly and firmly is that all business is today about the data. Good example is now the COVID crisis, because all the stores with just brick and mortar stores, all the businesses with just brick and mortar stores were definitely through the night cut off from their customers. So they were trying, and they are still trying, to find a way to the internet. And if you want to actually survive as a business, you need to be really some digital business. Yeah, without that, I suppose you will not survive in the future. And if we are talking that the business are the data, there you can name actually three pillars on which the whole business could be built. And this is the managing data. So taking the data, taking care of them and available data for your usage. govern the data, so cleansing the data, taking care of the data and usage of the data. And the last one, but not least important, is the securing of the data, because it's something mandatory, because data basically are the money for the company. So you have to be aware of that. And because we said everything is going to some digital transformation, so this is the key, how actually any business in digital transformation is able to be tech intensity. It's another buzzword from the last Microsoft from the last Microsoft presentations, which means that you have three pillars there. How actually your business is able to adapt, capable, and trust the new technology. And these three pillars are going to the tech intensity, and how are you able actually to move to the digital business. And because we said that the business is data, basically, we have definitely to analyze them. So in today's world, a part of the business is definitely the data analytics itself. And even if that maybe sounds strange, but I think most businesses already get that idea, even that they haven't known that. And from this point of view, you can actually divide it, working with the data into three pillars. Yeah, actually, you will see all the time through my part of the presentation that anything could be divided into 3 points. Yeah, but you can divide it anyway. But I try to stick to the 3 pillars. So, firstly, you have to use the data for decision, which is the first one. Business need to know thyself. Definitely, that's the big idea, and this is the big pillar. Second one, you have to empower the workers working with the data and actually available the data for them for daily usage. And the third one is usage of new technologies as artificial intelligence, because it is really opening a new door to another level of data processing. And if we are talking about the normal human analyst, we are talking that he is very capable. He is still working with some limited set of data, but let's say augmented intelligence, artificial intelligence can work with limitless data. Before I will pass to another slide, just actually want, if you have any question to the presentation, just put it in the chat, and we will, through the breaks, we'll try to actually answer your question. Yeah? So do not hesitate to write it just now. And to support these 3 pillars, you can use plenty of tools, and these tools can be also divided into 3, let's say 3 groups. Sorry. First of all is data science. Data science, where you are actually, it's not just about data analysis, it's about really thinking about the machine learning, and etc. So it's not just the, let's say, normal, in brackets, normal work of analysts, but it's also working through with the tools, etc. The second one is the scalability. In any business, you need to work with the data, and it depends on the case. Some of the cases you need, for example, the whole history of the data to work with, and in some cases you need just a set, a part of the data to be chosen. And in some extreme schemas, you can say that you would like to use these two parts all together at once. But as this is still something like analysis, you don't want to actually live with such a data and with such a set of data forever. Yeah, you will do the analysis and then you want to actually switch it off. And that's why you need actually scalability, and that's what actually cloud is prepared for. And the last let's say, part of it is, as I said, the machine learning and artificial intelligence, where some processing could be even autonomous, and even the decision making could be today autonomous without any actually human sticking the button. So now we move actually to why the businesses could move to the cloud. Yeah, you can see several triggers why your business should go to the cloud. Yeah, that could be some cash flow challenges. There could be the budget and resources constraint. Yeah, there could be some business continuity. Yeah, it's just a, let's say, overview. What could be the triggers which are pushing all the businesses going to cloud? And we understand that it's not an easy way actually to move and to change everything to cloud, but nobody needs to be feared by that, because, for example, Adastra has a variety of approaches, and I will just name it several cases which are a little bit connected to the previous slide. So they are the cases which we worked with the client, and we know that it's really the trigger and really the way how to do it. So first of all, the easy way is infrastructure upgrade. That means all your hardware and the technological level of your infrastructure is moving to the cloud. And that's quite easy way because there is no impact on the users. You will just change the hardware for the virtual machines, and that's all. Another interesting case was actually disaster recovery solution. That means that you are actually building the disaster recovery solution already on cloud. Yeah, and it depends how far you will get with the cloud implementation. But you are just building the disaster recovery solution, and when it's actually built and it's running and it was tested, then you switch to disaster recovery solution, and you can easily after that change the same way the live environment or the primary environment for your enterprise. And that's quite clever approach to that, because you are actually using the live environment, and you will see all the problems which appear during this implementation. And the third case is about enabling to that your firm really needs scalability. So switch on, switch off some databases very easily. That you need to use some of the tools which are available just in the cloud as SaaS services. And there is no other way actually how to get to these services that just cloud. And as I said, we as Adastra are able to help you in such a journey. And we know that there is a lot of there could be a lot of obstacles on the way, but we are trying to understand the business needs and what actually client needs, and we are able to help you actually go through the whole way from the beginning till the end to be actually cloud adaptive firm. And I suppose it's also inevitable for any business to get to the cloud. So it doesn't matter if you want it or doesn't want it. This is the way how actually the world is working. So that's mean you have to do something either way, or you will be stuck in the, let's say, Middle Ages. And as there was 3 pillars and everything was about 3 on my slides, so also this slide is about our approach to the actually cloud adoption. So first of all, it's a circle, as you can see, because we believe that it's a circulation all the time. So phase 1 is actually implemented, and that will change the previous phase, etc. But firstly, you have to draw a roadmap. So which step should be done and where you can go and how far you want to get to the cloud. Then from this roadmap, you will actually write the phase plans, and you will after that implement them. And after the implementation, you will get back to the roadmap and rethink the map if everything was okay, and if you are still want just this cloud adoption or another one, and then replan the phase plan, etc., etc. So actually, this is my last slide from the welcoming session, and I will pass the board to my colleague Martin Ben.
Okay, thank you, Kuba. And I will share my screen with our second section. So it's section focused on business intelligence, data warehousing, and analytics in a cloud, because it's the main topic for today. So let's jump into presentation. Yeah, our current world is based on just our modern data economy, or our new economy is based on data literacy. So it means that data are more important than before, and we use them in new, modern, innovative ways. And we can very easily create new data monetization models. So understanding your data is only piece in the puzzle is in today's world. We can build many sophisticated data solutions, being able to articulate your data insights to your organization in where real value is found. So it means we can support decision makers beyond traditional reports and dashboards. We can engage new data sources. We can work with modern technologies like big data, machine learning, or mentioned AI. So in this environment, being able to define a work with data-driven processes is essential. So it means we must be better prepared. So it means we need sources and tools which are still evolving, expanding, and they add new capabilities. We built data-driven processes which are essentials for modern enterprises. And the data literacy is a shared organizational practice. So these 3 pillars It's just the foundation for the modern data economy, because communicating with data or usage of data is a critical skill for each modern enterprise. So how to achieve it? So it's problem which needs some mixed teams. So users, it means business users, business analysts, some decision makers, and IT specialists must come together into new enterprise, because it's not about some functional separation or some functional focus, and these both words must be seamlessly connected together to deliver some real data value.
Čau. Hele, sluníčko, vyfotila bys mi
Okay, sluníčko.
na v autě, prosím tě, já jsem na to.
So,
Právě.
and just small problem for her.
No, dobrý, no, jasně, úplně v pohodě, pak mi to pošli. Jo, díky, pá, čau.
Okay. So we need to improve. Okay. Back to presentation. Okay. When we are describing the mixed teams, so what's the main topic for this seamless integration? So business users expect tools and services that work the way they work. So it means that everyone needs better solutions, better features, better technologies, better performance, everything better. And IT and business both need self-service analytics tools. So it means less work in traditional way, less some kind of hard coding, and IT no longer controls or constrains every aspect of the new enterprise. So it means that greater power comes with greater responsibility. Because today business users are tech smart, and they can use many different tools to support their analytical needs. And so there are also trends like bring your own device, where users expect self-service analytics, own dashboards and visualization. In enterprise layer with self-service analytics, IT cannot expect full control, and but you must somehow solve the problem. So IT must provision data and services and just monitor usage and security. So it's a different approach than 5 or 10 years back, because it's more about enablement than just about provide just some kind of IT delivery. Other important topic today is governance and self-service enhanced decision making, because governance is not about making the right decision, but it's about making decisions in the right way and in the right time. Because if we, as we described before, IT's new role, it's to provide well-managed tools and services to support effective best practices, even if they cannot guarantee the results. So yeah, it's also one change compared to the past. Services include curated data for business users to consume for BI and analytics. And there's also one other important topic, and it's a topic also for today. We all need platforms which allow self-service analytics. So it means data warehouses, data lakes, data science tool, and self-service analytics. So there are four categories of platform technologies which must be considered to deliver some proper data-driven culture or support data-driven culture. So another another topic or just game changer is the cloud in analytics, because modern businesses succeed in the cloud because cloud offers many advantages which can be very easy adopted. And for example, it's not example, it's a real statement. The cloud is a default environment for new technology initiatives. So it means that new programs or some new prototypes, new solutions are usually based or built up on cloud technologies, which offers much better conditions, features, less strict limits. So application increasingly cloud native. So there are many jokes about this approach, what it means, but now we are talking about some real approach in which applications are built with respect to cloud principles, including elasticity, high availability, availability. And another thing is that collaboration platforms and file sharing are transforming. So it means not only the cloud, but we can also access our data worldwide. We can access our data from different devices. And somehow we must think about how to merge our on-premise environment and the cloud. So the first generation of cloud solutions is usually somehow based on hybrid approach. So hybrid businesses are replacing on-premises data management, but now they cannot replace it they cannot replace everything. So now we are usually solving the problems how to get your data into the cloud or how to get your business into the cloud to get our advantages of the cloud to your hands. So because there are many strategies how to solve it, but without some proper strategy, you can be very easily lost in your cloud program or cloud direction, and you must think about the cloud as about opportunity. It's not a disaster, it's not disadvantage, but it's a problem. It's a great opportunity because the cloud enable projects that are easy to start and easier to scale, usually with some different price than you expect, but it's about some learning curve. Uh, for example, there are some very good examples because, for example, we can mention Cloud CRM, Microsoft Dynamics 365, or we can mention, for example, Salesforce, because all these applications can be cloud native, and there's no reason to solve data management out of the cloud in on-premise environment in these cases, because you will face many problems with your data analytics. So the standard or the best approach to solve how to succeed in the cloud is think about some hybrid approach, because there's only one exception. If you are building your enterprise or business on greenfield, you can be cloud native from the beginning, but in reality you have some kind of legacy which must be somehow solved. So, and that's the reason for some hybrid approaches. Okay, I think that the most critical question or issues with cloud is usually the questions about security, because when you are thinking about cloud, you are thinking about some Hollywood movies with hackers hacking secure systems in 3 seconds. But cloud security is really different, because cloud security offers a new level of protection, because there are many services, or just standard services are very secure, and you can also use the many security services in additional to improve your security, and they are usually much better and more advanced than standard security tools or features which are available in your on-premise environment. So business benefits from built-in security found only in the cloud, because it's about some kind of proactive approach, some special security departments. So if you have your security department, so you can believe that Microsoft or other cloud service providers has at least 100 100 times more specialists than you can ever have. So there are some examples. Data warehouses in cloud store their content under lock and key, because usually everything is encrypted in the cloud. Cloud security is proactive in detecting threats, so it's a very advanced security style with many AI-driven components, many advanced inspection techniques, many types of firewalls and security rules. Cloud security offers vital resiliency and availability. That's also important statement, because resilience and availability are not just good objectives, but vital security feature for global always-on services. Because you can think about how to cut your cables in your on-premise environment, but in the cloud you must be more advanced. So in the cloud we can talk about geo-replication, point-in-time restore, the high availability. So usually heading to the highest availability available, because you can store your data or have your computing resources all around the globe, and use them in case of some accident in your area, because you can be sure that you will get your application or analytics anytime. Okay. Yeah, the main topic for today, or one of subtopics for today, is data warehouse. So data warehouse originally was created as a logical concept. So it means it's not limited only to the on-premise environment. It can be also moved to the cloud, because, as was mentioned in one of the first slides, we have data warehouses for last 30 years. There were many revolutions, many evolutions, many upgrades. So it's still, after 30 years of evolution, it's still key data platform, and it's still valid for today, because it's still the data system used for reporting and data analysis in some standard or traditional way, which is still about more than 80% of standard analytics. And it's a foundation component for business intelligence, because there is no better way how to get data from more data sources, get them to one place, and somehow integrate them and use them for your data analytics. So it's a very mature concept, and this concept can be very easy shifted into the cloud, because it's more logical architecture than just some set of technologies with limited possibilities to be somehow migrated, because data warehouse is technology agnostic. So it means it's database and not only relational one. and other features are focused in logical ways how to build it. So it means it's based on subject orientation, data integration, and data history. And data warehouse is also stable in time. So it means you can perform your data analytics or your reports or some of your calculations now, and you can calculate the same thing in next 20 years. Even if you will add new data sources, you will get new primary systems. So that's the reason why to use data warehouse, because it can simplify many things, and you can use it for at least 10 or 15, maybe 20 years if it's properly built. And if you build it in the cloud, I think that it will add additional 10 years of lifespan of your data warehouse. So it's not everything is not only bright. So we have also some dark side of data warehousing, because current data warehousing, because there many of them were built more than 10 or 15 or 20 years ago. They face many challenges, or it could be also called opportunities, or some problems, because what's changed is it's not data warehousing, but the main change was some kind of change of paradigm how to use data. Because 10 years ago, so you have data, and it was something usually called like exhaust. So it means you have data because you must run your business, but it's changed, and now you have data, and it's a great opportunity. So business change their mind, and now business needs are very real. So it means business expects growing revenue and profit, but it was the same like 10 years, 10 years before. Better products and services. Also, it's great idea to use some data to improve it. Better customer experience. So how you can measure or evaluate the customer experience without any data. Regulatory compliance, because all last crisis showed us that you must somehow be aligned with some regulatory rules. Smarter business, so yeah, you can do things in smarter way if you can, and if you have proper tools, smarter tools. Data-driven decisions, faster responses to new challenges, agility. Also, you need to be faster in everything and be agile. Digital transformation, it's also a great challenge, not only for data warehouses, but for every business. Data as asset, also we can think about the data as a product. So because it's not something something without some borders or impact. So you can also think about data as a product for some data consumers. Advanced analytics, because you can use many different algorithms to improve your decisions, to improve your knowledge, prototyping, and automation. But on the other side, data warehouses from original concept or from original building period have many issues, because in standard data warehouse environment on premise, you have limited resources for business solutions, because you must buy new hardware, you must maintain your software licenses, and it costs a lot of money. You are facing growing data volumes, because we are talking about some kind of data disruption, data boom, because we usually collect every 12 months more data than the humanity in the last in the last few thousand years. Batch data processing, it's also a problem today, because it's usually based on some strange time windows like month and week, and I'm not interested what happened 2 weeks ago, because I'm interested what happened yesterday, what have happened in the morning. significant data latencies, so I should not wait infinite or undefined time for my data assets. Suboptimal performance, so it's usually very hard to somehow improve your data warehouse experience with insufficient performance, because many tasks are too slow, and you must still wait for something, and you are not working, but you are waiting and waiting and waiting, and it's a huge problem of efficiency of some workday of your workday. Threat of perfectionism, yeah, it's also a problem of some on-premise solution, because they were built with too strict rules, and they cannot be easy extend to new conditions or to support new analytical tasks. Limited data analytics, so it means data warehouse on premise is usually something like it's warehouse, so it means it stores data, but there's no reason to distribute the data for data consumers, and it's problem with many data warehouses. Uh, High total cost of ownership, yeah, it could be very costly if you are using some very expensive, usually high performance but very expensive technologies. Increasing overhead costs, so it's still more and more complex, and everything is old, old-fashioned, and weird. So you must solve it with additional costs. Limited or no scalability. Yeah, it's a problem for some, for example, because in some standard data warehouse environment, you need top performance only for a few days in month. It's usually some kind of a monthly closure or some specific days in week, because you are usually solving, for example, on Tuesday, your on Monday reporting from the last week. Old-fashioned governance, because now it's also a modern trend to improve the governance of data solutions, because it's as mentioned, so it's greater power comes with greater responsibility, and old-fashioned governance was focused on processes, but now with modern technologies you have more options, more variants how to solve the same problem, and the governments should help you to improve your experience or your approach to fulfill the solution with less obstacles. Okay, next one, lack of self-services. It's also a common problem, but with cloud technologies from Microsoft, including Power BI, you can solve it very easy. Missing data ops, data operations is also a modern trend, and you must think about your data platform like about other application, but you cannot apply DevOps easy, because it's not focused on data. It's focused primarily on features or on applications. So you can use data ops to improve your data warehouse, but it's very hard to apply it in on-premise environment, because your solution has some roots, some foundation principles, and you must respect them, and it's very hard to improve it into some better way, and it's also good reason to shift to the cloud. Yeah, and the last one, we usually have yesterday solutions facing today challenges. It's a very common problem, because we have some major solutions which were built under certain conditions, but now we have little different conditions, or we are facing to the real data boom across all industries, and we must somehow evolve our data warehouses into more upgraded or better forms. So it's about the evolution. Yeah. In reality, so businesses are forced to maintain two critical yet independent analytic systems. So there are usually about two domains in your data management domain. So it's standard business analytics. It's on the right. And you can send it's about relation data, proven security and privacy, dependable performance, structured. So it's usually solution based on some kind of data warehouse. And but the new one trend, or it's trend for the last 5 years, you must somehow solve new data sources which are not so well structured. So there was the reason in the past why I use them with some limits or in limit scope. So it's a domain of data science. So it's about big data, experimentation, fast exploration, semi-structured data. So it's usually about some kind of data lake or big data platform. But in the business, you must solve both problems because business analytics is about your major part of your analytics needs. But you must somehow improve it. So it means you need also the data science because the approach to data lakes and data warehouses, it's also synonyms for data science and business analytics, differs in a couple key areas. Data lakes tend themselves to be massive, semi-structured, to allow fast exploration and experimentation, and it's not without some side effects. So it means the clean data. It's a common nature for every data warehouse or every properly built data warehouse, because there are also some improperly built data warehouses, but it's not topic for today. It's a little different because standard data warehouse provide some better security, privacy, some some dependable performance with structured and relational data. So you must somehow mix both these domains together, because both of these systems are important to deliver important to deliver the business value to you. So if you want to somehow monetize or capitalize your data, you must invest into both domains. And so it means also to invest in not only into some concepts or governance, but you must somehow invest into your teams, people, and also in technologies, because you cannot perform your data science with some proper data science tool based on R or some other legacy technologies, including SAS. Sorry. So, yeah. Another problem which you must face is also digital transformation, because there are some statistics here. 91% of business leaders see digital transformation as a way of sparking innovation and finding efficiencies. It's not possible without data. 68% say digital transformation is increasing profit, so it's also important, but you must still somehow improve your digital experience or your digital culture to fulfill your business requirements and needs. 85% say they must offer digital services or become irrelevant. So it's not only about the better profits, but also about some survivability. So you must, if you want to survive, you must undergo digital transformation. 64% say they have less than 4 years to complete a digital transformation, or they may go out of business. So it's a very important statement, because you cannot survive without your digital program or digital projects, because some organizations are embracing a digital transformation journey and feel excited about it. And we see organizations which are reaping real tangible rewards. So the positive disruptions are truly amazing. But we also acknowledge that for some, the whole topic of digital transformation is causing tension. There are legitimate concerns about getting digital transformation right and in truth. because the future success does depend on making this transition. So let's step back a moment. So there are some things that can help demystify the whole topic a bit, but you must think differently. And these numbers support this statement. Okay, so when we are talking about data management in modern data warehousing and business intelligence, it's not only about the data warehousing, which is covered here on uh, on on the left side with some traditional OLAP cubes, star schemas, snowflake schema, but it's also about the usage of your big data. So some graphs, some geodata, documents, images, voices, other documents, some computer logs. But you must think also about your fast data. So it means some real-time vision, sensor processing events, and in many cases you must solve also deep data. So it means it's some processed set of big data and fast data, which are somehow improved and cleansed and transformed into specific cases. So you are, for example, getting data from sensors, but you must select only the proper features or proper settings, proper precursors to build your effective machine learning algorithms. And there are also dark data, so it's here to mention one important problem. If you are not using your data, and it doesn't matter if it's data for data warehousing or big data or fast data or deep data, so it's the problem with dark data. It's about the data which are stored, which are sometimes also maintained, but they are not used for anything. So it means you are wasting your money with dark data, and you must think about all your data assets, how to use them by your data analytics, and you can use them for reporting, business intelligence, data visualization, data discovery, predictive analytics, planning, recommendation, and more advanced topics, segmentations, machine learning, data science, network analytics, and automated decisions, which which can help you improve your business and get your profit. So that's very easy simplification. Yeah, another important statement here is the change of data analysis paradigm, because if we are thinking about our past in data management, and we have a very long past in data management, our traditional solutions were built in old ways. So it means we structure data, ingest data, analyze data. So it's traditional data warehousing, but in our big data boom world, we must think in a new way. So it means we must somehow ingest data. We can use, for example, streaming platforms with some variable data formats. We must analyze our data, so it means we must process them, and we must somehow structure them for further usage. So it's a big change, and you can see it's not only about the changing order of steps, but it's also the change in mind how to use data, because you can use them very quick, but it means you need some proper technology stack which allows you to do it. Another thing to consider is evolution of analytics, because we always start with descriptive analytics. So we are describing what happens in the past. So descriptive analytics. So it's what is happening, what happened to my business in the past. But sometimes we must think about diagnostic analytics, because it's more deeper, because diagnostic analytics is about data insight, which provides some answers to questions like what is happening in my business, but I must somehow understand some consequences. So it's about diagnostic. So it means about the details. I'm looking for some root causes. We can talk also about drill down, because descriptive analytics is something on the high level, and diagnostic is about some specific subset or some deeper level, the lowest level of your reporting. But in evolution, what happened next was predictive analytics, because predictive analytics is about some predictions. So it's you have your past data, and you can use your data history for not only for future, but to predict what will happen next, because you can use some AI, machine learning models, or some statistical models to describe your future. So you can, by building our predictive patterns on top of your data, and by utilizing the data finding in descriptive and diagnostic, you are able to identify what is based on what you get from descriptive and diagnostic analytics, and use to find answers to questions: what will happen in the future? What are the trends? What are the patterns? So that's about the predictive analytics. And in next steps, you can think also about the prescriptive analytics. So it's technique or kind of analytics which is used to provide a predictive insight into your data. And you can also determine the best course of action to choose to bypass or eliminate future issues, because because the predictive analytics is saying what to do, but prescriptive analytics is saying what to do, but with some real action. And the final step is cognitive analytics, which is more complex than previous one, because cognitive analytics must combine a number of intelligence technologies like artificial intelligence, machine learning algorithms, deep learning, to apply human brain like intelligence to perform certain tasks. So it's some kind like predictive analytics 2.0, but in more complex way. So basically, this type of analytics is inspired by how the human brain processes information, draws conclusions, and codifies instincts and experience into learning, such as understanding not only the words in the text, but the full context, what is being written or spoken. So it's more about some deeper data processing, and you also need some very complex or advanced technologies to implement your cognitive analytics. Yeah, one mentioned topic was data ops. It's only one some side step. Data ops, it's also important topic, because you must think about your modern data warehousing or your modern data lake in data ops way, because it's not only about some programming or data processing, but you must think about delivering the value, because data ops is based on, I call it data ops T, because you have two pipelines in data ops. One is called value pipeline, so it's some regular operations of your data management solution, and you have innovation pipeline, which is focused on prototyping, verification, standardization, and extension or some kind of upgrade of your value pipeline. So we are continuously perform a pipeline, and in some iteration steps, you perform an innovation pipeline. And there's also other related domain for this topic. There's also called machine learning ops, which is also new trend. So there's also way how to standardize and how to productize your machine learning into some kind of process landscape. So basically, data ops is it's about bringing a new value, and it's connected to strict quality control. So it means that your quality control is focused on both parts of the pipeline, And there are also some principles, because there's also something called Data Ops Manifest. You can sign it if you want. So main principles are self-service instead of data request. So as we mentioned before, so it's the main topic about some smart tech user which can use many advanced technologies. Automation instead of manual processes. Yeah, you also mentioned it's also needed by business, and it's also the problem of some standard data warehousing and business intelligence. Frequent small changes. Data scientists, analysts, and data ops engineers must be a single team, so it means some seamless integration of IT and business together. Value brought to business is a primary progress measure. So yeah, that the process is also about measuring the success of your data ops. That's native part of each data ops implementation. Continuous attention to a technical excellence in data design as simple as possible, and self-organizing teams with continuous improvements. Yeah, it's also about the agility, growing and growth, and it's describing how to do your data management. So yeah, so what it was data ops, and so we can now focus on data warehousing, because we describe many problems, issues, and opportunities. And the modern data warehouse is an economical breakthrough. It's not only the technical one, but also economical one, because it's about the price, performance, and agility. Because price is good, performance is excellent, and agility is also excellent. And high infrastructure costs are avoided with cloud-based data warehouses, because it eliminates the need of large capex investments. Deploying your data warehouse in the cloud is faster, easier, and more flexible than a traditional data solution, which is very slow, because you must buy new hardware, you must deploy it into your data center, you must install everything, you must set up firewalls, you must manage many different teams. So in the cloud, we are managing only part of the problem, and the slowest part, it means the technology one, it's solved by the cloud provider. Iterating designs and handling diverse data is far more efficient than for on-premise solution, because you can add new environments, you can try new features, you can use some integrated features to improve your design very easy. And also elastic scaling makes world-class performance available to all users. So today we will describe more in detail Azure Synapse Analytics, but there are also other modern data warehouses. But today it's about the Synapse, because Synapse Analytics optimize analytics and operational workloads with elastic scaling, and it's a huge benefit for each analytical solution. Yeah, the modern data warehouse is the hub for all data models. It's also important statement, because there is also new term which is used for this topic. It's not only about the modern data warehouse in the cloud, but you can hear about the term called lakehouse. So there's no problem to store structured, unstructured, and streaming data integrated in a single scalable environment, because modern data warehouse, it's usually the mix of traditional data warehouse and of data lake. So workloads can be stored, managed, and provisioned together. You don't need the jungle of processing schedules, because you can use some simplified scale of enterprise tools. And one important thing, or other important thing, is visualization and data science tools empower enterprise-wide insights. So there is no problem, because it's no problem to use enterprise models, BI sandboxes, and predictions, because they can be stored in your modern data warehouse. You can use enterprise ETL self-service data wrangling for data processing, because both are efficiently handled with no need to jungle some processing schedules. And you can deliver enterprise-wide reports and enable ad hoc data discovery. So it's very easy with data visualization and data science tools if you need them. Oh, here's some comparison. You can see that cloud has many advantages compared to the on-premise solutions. We can compare it in 4 domains or 4 areas. The first one is about the procurement. I think it's the painful part of on-premise environments, because it's usually slow. It's about many contracts, complicated processing, large finance volumes, starting with long-term contracts. But in the cloud, you can use fast provisioning, optimized contracting with some bonuses for long-term contracts, or you can use pay-as-you-go model. So you can use it for some prototyping. You can start from zero budget, so it's very simple. If we can compare deployment on-premise, it's about cumbersome projects with too many constraints, limited options, and multi-domain problems. In the cloud, it's about the instant deployment, because problems are solved by someone else. It's usually solved by a cloud provider. Optimize out of the box, because there are teams of engineers focused on optimization of the cloud services, and they are still continuously working. Easy stop and start later, so you can, in many cases, you can stop your service for a while, or for a week, or for a month to save your money. And the cloud is also based on virtualization and containers, so it's some native way how to do things in the cloud. It's also possible in on-premise environment, but it's not so seamless like in the cloud, which is something like client-server architecture of the next generation. So everything is more advanced, it's more abstract, and it's important to say it's easier to use. About the features in on-premise environment, because there are many budget constraints, you have limited set of features, complicated management, because management is usually costly, traditional workload and processing. New features are usually limited to some upgrades or some buying of new components. In the cloud, you can use wide and extensible set, automated management, any workload, any processing, because you can mix different services if you need them. About scalability, yeah, on-premise environment has two problems, which are switching, and you are usually faced because you have static pool of resources usually. There are some special solutions with some possible scalability, but it's not topic for today. So we are facing two problems. We are facing to under provisioning in the first phase, and after under provisioning, we are facing to over provisioning or in opposite way. So it means you can start with over provisioning and then continue to under provisioning, because it depends how you originally created your environment. So it's usually you are never in some equilibrium state. So it means you are still facing one of these problems. And the scale up means time and money, and it's usually very hard to scale down. So it's usually impossible. But in the cloud, you can use horizontal and vertical scalability. You can fast scale up and down. Down it's more complicated, but it's less complicated than on-premise environment. And you can scale for defined time, so it means you can use the performance, some top performance for some peaks, because you have some monthly closure for some special reports. You can add some power to get result faster and make your decisions quicker. So how to how to get to the cloud. So there is a one. You should start with some smaller steps. And as Kuba mentioned, it's infinite process, but you can start with something like cloud sandboxing or some VR environment. But the cloud sandboxing is very safe because you can try everything and somehow get experience or idea how to use it in further stages. Next one, recommended step is to build a cloud data science platform. Because you can get some advanced tool very easy without needs to solve some standard problem with data science tools, because you must know what you need, how to use it, how to integrate it with the rest of your stack. And the last step is about a cloud data platform. So it's for me it's the final step, and you can perform all your data management or your business analytics, data analytics in the cloud. So it's the most complex problem. Okay, something more real. Here's some of our case studies. So it's case study of one of our real customers from Canada, and you can see they used Azure Stack to build a cloud data platform. In the middle, there is a Azure SQL data warehouse or Azure SQL DB. Now it's called it's just the, maybe you can call it now Synapse, because Synapse is evolution of Azure SQL data warehouse. For analysis, there is a Azure Analysis Services, and for some visualization and data consumption, there is a Power BI and Power BI services. For some more advanced processing or some data science, there is a set of tools which can be considered to be data lake. So Databricks as a managed Spark service, which we will describe later. HD Insight as Hadoop platform, and Data Lake Analytics. It's extension of the storage. Yeah, Data Lake Analytics, and yeah, that's together because it's Data Lake Analytics and Data Lake Storage. So these technologies originally were created together. So now we can see that you can build your full scope data platform just in the Microsoft stack. In the Azure. So it's very easy. I can see you can store your structured data, semi-structured data, unstructured data. You can also consume REST API. You can integrate data from IoT services, from some kind of service through Azure Event Hub and Azure Stream Analytics. So this is the real example, and it's very simple to build. Okay. As we mentioned, it's also about the governance. So without the mentioned solution, the case study is very complex in the way of governance. So you must think about the data governance, because you are building something very easy extensible, but you can select very bad technologies for your solution. So here's just the example, and from the lake, which can very easy be become data swamp. So we must think about your data governance, how to manage your data all the time. Okay, section 3. So we started with some case studies, so we can continue. It is just the how to very easy create your cloud data warehouse or your data lake house in Azure, because you need some few components. You need something for data ingestion and data processing. You need something for storage and access, and you need something for consumption, and you also need some data sources. So it's only a while, and now let's talk about data sources. So as enterprise system of record for business processes, the data warehouse is mostly built over line of business data sources. So it means it's some standard approach, but there are many data sources. So this part that data are unstructured, structured, or semi-structured. The modern data warehouse must handle it. So these data sources are usually used for some more advanced processing with your data science platform. So in this case, it's Azure Databricks. About data ingestion. For data ingestion in this architecture, there are two components which we will describe later. It's Azure Data Factory. So Azure Data Factory, it's something like ETL tool, but it's more advanced because it's evolution. So Azure Data Factory schedules and orchestrates data transformation and bulk loads. Meanwhile, Azure Databricks, so this part, performs transformation, especially for data science, and also builds and execute models. So if you are thinking about machine learning and AI and some predictions, so it's here. So it can score models, and these models can be loaded into the data warehouse, and it's here, or it could be integrated, and it can provide some insights for your enterprise applications or for your reports in Power BI. About storages and serving, there are two storages here. Azure Data Lake may be used to store raw data in high volumes for later use, and it's very cheap, along with staging transform data from Azure Databricks. So it's about this arrow. Azure Synapse Analytics provides high performance, high scalable data storage for enterprise models with outstanding security, governance, and manageability. Yeah, because this part is the pure, or it's modern data warehouse, and this part is it's not the data lake, and together they can be considered modern data warehouse or modern lake house, data lake house. And about the data consumption, Power BI users are usually very important in every enterprise, because if your business users find Power BI, you must somehow support it because it's very easy to use. So Power BI consumes sanctioned enterprise data from the data warehouse, so from this, or from the data lake storage for reporting and analytics, but also but they also use from data lake, and it could be used for some regular reporting and for ad hoc analysis. So, and about the business services, many business services, including line of business application, consumes data from the data warehouse as authoritative, governed, and source of enterprise knowledge. So, okay, important question here. If business users are tech smart, and they are usually tech smart, and they data literate, so they can understand data, why do they need enterprise models? So it's about some reasoning for Azure Synapse Analytics, because enterprise data models are for three things, or there are three features. Consistency, because some business processes can be built once and shared as corporate standard, so it's about the efficiency. Governance, certain data tasks need complex security and privacy control, so it's about quality. And efficiency, no need to repeat design, preparing and loading or securing. So that's the reason why to use some enterprise models, which can be used and reused. And about flex, and their using is flexibility. So if enterprise models are so important, why do users need the self-service BI models? Because it's about the flexibility and efficiency. Because some datasets are temporary, external, or ad hoc, and don't need to be consolidated, because you have some dataset with limited lifespan, and you can throw it away if you don't need it. It's about efficiency because tech-smart business users have fresh and innovative ideas they need to explore with agility, and you cannot follow them with your standard IT processes. That's the reason why the process of building centralized models to support all these initiatives is too cumbersome, but successful and widely adopted business intelligence models may be refactored into the data warehouse for future enterprise use. So it means that you can collect or somehow productize some new new models from your ad hoc processes into your business data pipeline. And what is the role of the data warehouse with data science? Yeah, data science is also important for us because it's about integrating a result with the enterprise models, making the result of data science easily available for business functions, and serving enterprise data for data scientists because it helps ensure consistency across diverse analysis. So here's a one this is a simple comparison, because if we are thinking about your data models or data landscape, you also should think about how to organize it. So one topic or one solution or one option is to use enterprise models because it's built and maintained by IT architects, consolidated data from many sources, centralized as an authoritative sources for reporting and analysis. So it's usually we are talking about Azure Synapse Analytics. BI models, so it's about the consumption of data. So it's built and maintained by business users or BI developers, use enterprise models, departmental data and external sources. It's focused on single subject area, but often widely shared. So it's about the data distribution, data consumption, data sharing. So you must also solve some kind of security because there are some data which cannot be seen by someone else. And the last part of your data model should be machine learning models. It's about today it will be about primarily about Azure Databricks, but we will mention also Azure Machine Learning. So it's built and maintained by data scientists, mostly developed from raw sources in the data lake, and often experimental. So it means it's usually not used anymore after some validation, and there are some data engineers needed for further production use. So without, it's also about some innovation pipeline which must be somehow integrated with your standard value pipeline. And the main topic for today will be Azure Synapse Analytics, which is its limitless data warehouse with unmatched time to insight. So it will be described in the next sections. It's a set of tools with some query part, analytics runtimes, and store, and it's very easy to use them. Okay, so let's continue. Here's just a short overview of Power BI and Azure Synapse Analytics, because together they bring market-leading BI platforms, so it's confirmed by many reports, and industry-leading data warehousing engine in Azure Synapse. Power BI can analyze and visualize massive volumes of data. We will show it later. Azure Synapse Analytics provides a scalable platform to enable real-time BI. So it's no problem because standard performance of enterprise data warehouse is very limited, and it's a good idea to use something more advanced and with better performance. And Power BI users wishing to analyze real-time on unstructured data need a scalable platform which can be queried easily with familiar syntax and connectivity. Okay. One of final thoughts before we will look into some concrete technologies, that data warehouse or lakehouse still has its mojo, and it's only getting better with new features and new technologies. And if you are thinking about cloud-based data warehouse or lakehouse, based on Microsoft technology. It's about the usage of Azure Synapse Analytics and Power BI. So yeah, what to think next? Okay, yeah, here's just the final thought. Azure Synapse Analytics lies at the heart of business and BI, so this is the central component, and that's the main topic for today. So we will describe it in some more details. But now we will look into this part. It's Azure Data Lake Storage, because it's the first technology we will describe today. So we will describe Azure Blob Storage and Azure Data Lake Storage, and we will describe some differences between them. So we will look into data storage and surveying, and especially to this part. So it's about the Azure Lake Storage. And so why we should use cloud storage? Because there are many reasons. Because there are two main points. One is reliability and security. When we are talking about reliability, we mean that you will always to be able to access your data even when bad things happen, and it happens sometimes, but you must think about it. Every time you write data into Azure Storage, Azure automatically goes to create the last 3 replicas of the data. What it means that if one of your server or disk or data set will fail, you can still use your data from one of the remaining replicas, and the end users usually won't notice anything. So that's the reason, because the cloud storage is built in more robust way than standard storage. So it's about that. If we are talking about the cloud storage, it's about it also make your database always available. You can use different strategies for different data sources. So you can store blobs, tables, relational, no SQL. You can tune and maintain your databases with predictable performance, because you are paying for performance of your storage. You can access, share, update data regardless the type and device. So anywhere in the world, you can use different storage tiers. You can access your data quick from around the world due the replication and multiple data centers. Cloud-based storage offers also standard APIs to access data, so you can use third-party tools, or you can implement your own. You can also benefit from fully managed DBs. So it means you are caring only about the data, and the rest of the maintenance and some basic management is on the side of the cloud provider. You can also use cloud storage for your data analytics use cases, and on the other side of additionally, you can monitor, troubleshoot, and manage at scale your cloud storage. You can also use automated backup and recovery. So there are many reasons, and if we can compare Azure Data Storage versus on-premise storage, it's about few notes. So it's about the cost effectiveness. On-premise requires dedicated hardware, which needs to handle peak demand, and compared to the Azure Data Storage, is pay-as-you-go and scalable. So it's ready for demand fluctuation. So you can think about the different use cases than before. And so you are able to scale up and down easily, because it's only about the billing. So if you need more performance, you will pay more. If you need less performance, you will pay less. So you can think about it as something like magic button or magic driver, which can be used to improve your performance. The second reason is reliability. So between replicas, data protection tiers, and the global footprint, having all that built into Azure and available as a service makes maintaining reliability much easier. So it's built by the cloud provider. When things are available, customers and users are happy. Yeah, because they get what they want. So are executives. So it means it's also an important part of your business, and they are the one who approve rises. So with good reliability, it's very easy to somehow advocate the usage of cloud storage. And finally, you can think about different storage types. So you are able to store many different kinds of data in a single Azure storage account without having to deal with multiple servers, management interfaces, which is standard for on-premise environment. So it's a huge benefit because it's a great simplification, and Azure can offer some scenarios where you can have some of your data on premise and some in the cloud, and then you can somehow synchronize them because there is also support for hybrid scenarios. Okay, about the Azure storage account in the cloud, about what we can store. So you can store blobs, and it's object storage which can be accessed via REST. You can store files which can be accessed via Samba service and REST. You can store queues and access it with REST. You can store tables. It's no SQL storage. You can store whole disks. So there are different scenarios: streaming, lift and shift scenarios, scheduling, asynchronous tasks, key value stores, and persistent disk. And it's all built on a unified and distributed storage system. So it means that there is only one distributed system behind, because it's some kind of to get all features to one place. And it means durability, encryption at rest, strongly consistent replication if you need it, fault tolerance if you pay it, and auto load balancing. So you can use all these features. So it means there is no problem to store any type of your data in Azure storage. Next part, it's about how to about the relation Azure Data Lake and Azure storage. There is the definition, original definition for Azure Data Lake. It's a single store of all data. It's ranging from raw data, which implies exact copy from source system data with some simple processing or preparation or validation, because you must usually solve some problems with data formats to transform data which is used from various forms, including reporting, visualization, analytics, and machine learning. So here's just a simple diagram, because Azure Data Lake, it's a set of technologies. So it means it could be HD inside. So it's Azure variant of Hadoop distribution. It's about data lake analytics. So it's the main part. But today we will talk about Azure Data Lake storage, and there are two generations, generation 1 and generation 2. And if you are new to Azure, you will start at generation 2 directly. But if you are some of more major Azure users, you can also have your solution built on generation 1. So Azure Data Lake storage. So it's fast, it's scalable, it's secure, it's cost effective. There's a massive scalability. It's a near limitless storage for analytics data. There's a cloud object store pricing, so it's the same low-cost data storage model as Azure Blob Storage, because it's based on same stack of technology for generation 2. Few file and folder transactions, because you can also use atomic transaction for fewer compute cycles and faster job execution. Granular file and folder security, because there is a POSIX compliance. So it's great because you can define some kind of complex security model. Simplified ingestion in a single store, so consolidated data storage using the Data Lake Storage Generation 2 or Blob Storage REST API. It's important to mention generation 1 because it's extension of Azure Blob Storage with some name. There's additional namespace compared to the standard blob storage. Full Azure blob storage feature set. Yeah, I will show it later in labs to describe what's the difference between generation 1 and generation 2. Role-based access and storage account firewalls, so you can very easily secure your solution or data in your Azure data lake storage. And there's also support for common data model support. Its ability to exchange data with powerful applications like Microsoft Dynamics 365 for CRM or Power BI. So that's here are some highlights for Azure Data Lake Storage. So it's fast, it's scalable, it's secure, and it's cost effective. It's the reasoning why to use Azure Data Lake Storage. And if you combine it with Azure Synapse Analytics, you can get more with less. Okay, now it's time for Azure Synapse Analytics. Okay. Kuba, can you start with Azure Synapse Analytics? Okay. I feel like alone.
No, I'm here. I just will share the screen. Yeah, it's okay.
Okay, so yeah, I would start it, so it's no problem.
I understand.
But it's your turn.
So wait.
Yeah.
I'll share my screen, and that will be.
Yeah.
So now, I suppose you can see my screen, Azure Synapse Analytics.
Yes.
Okay, so thanks, Martin. So I will be talking a little bit about Synapse Azure Analytics and what it actually brings. What is Synapse Azure Analytics? It's actually binding together several services. It's not only the relation database, but binding several services together. It's the real data warehouse, SQL data warehouse as it was in Azure. And it's binding also data lake, sparking tools and sparking pools, ingestion spark, and everything. What are the features? There are new features if you compare it to the SQL data warehouse. And the most actually nice of them are the limitless and the possibility of pausing the data warehouse. If we are talking about some business case, and actually you can see what is it about. It's about actually the Azure data warehouse as it was in providing from Microsoft, and built on that are some limitless features. So if we are looking how the business cases are done with the Azure Synapse, you can see here some of the firm. ABN Bev is using actually the Synapse for actually just the analysis. So they know that they do not need all the data in their data warehouses, and they are using it for actual ingestion of data and putting the data into some form which could be easily processed after that in their data warehouse. New on the opposite side is using actually the scaling ability of Azure Synapse. So they knew that if they actually are having some marketing campaign, they can scale it to the marketing campaign and then switch it off. And the last one, the merit, is actually using just some of the services which are coming with the Synapse. So usage of the Spark tools, usage which could be also used in Databricks. So usage of the Python code, C#, and other words which you can actually input it into the predictive analytics, and which you can use in usage of machine learning. So these are 3 examples how you can use actually the Synapse itself. And as I said, Synapse is putting together several services. So they are not only the structures data. If we are talking about the modern data warehousing, they are not just the structures data, but they are data also coming from IoT services or IoT machines or whatever. There is also the ingestion part and the analytic part, as you can see in the advanced analytic. And what is it? Is actually the performance of the Synapse, which is a very good new feature, and which is moving actually the processing of the data to real-time analysis of that. And on this platform, you are actually able to use some machine learning. So, as you can see, I suppose you have seen already this picture from the Martin presentation, but this will be here several times, and you will see it. I suppose more than once again. But this is from the actually Azure Synapse Analytics point of view. So as I said, on the left, they are the on-premises data where can enter actually the analytical transformation. But they are also the cloud data. That's mean from any other clouds. Yeah, it's the same like from SAS data. This is from any services. It don't need to be just the Azure cloud service or Azure cloud. And as I was talking, it's about the device data, like from IoT platform, and everything goes to the first stage, which is the ingestion. It is normally used in data warehouse. It is normally used Azure Data Factory for that. And this is the first step. And the second step is actually the analytical platform, where you have the Azure Databricks for some reason to prepare some of the data if they are not well structured, or you have to actually make big changes. Then it's nice to use Databricks. And the final state of the analytics is the Azure Synapse Analytics, where you can do actually the analysis. And above that, you can build the Power BI or any other face to actually present the data. Azure Synapse Analytics is tightly connected to Azure Data Lake storage. Yeah, without Azure Data Lake storage, you do not have, you can actually use Azure Synapse Analytics. There's no way how to use it. What I want to actually stress on this picture, that in some cases, I'm not saying that it's quite easily, but what is the feature of the actual Azure Synapse Analytics? So there is a way that you actually skip the Azure Databricks and skip the Azure Data Factory, because all the models and all the features are actually in this Azure Synapse Analytics. Yeah, I know the cases where you can really need to use the Azure Databricks because you have to prepare the data for analysis. I know some cases where you have to use the Azure Data Factory, but in principle, Azure Analytics is actually targeting the place where you will use just it. So you will use just the data lake storage as a storage account, and then above that, you will use the Azure Synapse Analytics for mostly everything. Just the presentation layer will be somewhere else. So, from once again, another view on the Synapse. This is just the layer view or what you can actually get in Synapse. As I said, yeah, Azure Synapse Studio is actually integrating the integration, management, monitoring, and security. So everything what was done in history in Azure Databricks or in the ingestion part in the Data Factory could be actually implemented in it. And you can use the Azure Machine Learning. There are more than 100 services of machine learning which you can use actually from the cloud. Yeah, so you don't need to development. You can use them just as they are. And there are two parts from the technical point of view in Azure Synapse. There is the SQL database and SQL data warehouse and the Spark engine, which is providing Spark pools for the machine learning and for other cases, and for the actually the quick processing of the data in real time. And under this one is, as I said, the data lake storage. Without that, you are unable actually to use the Azure Synapse. Yeah, and above that, you can build Power BI, Tableau, whatever you want actually to build above that. So, what are any other innovation in Synapse? First of all, there is a modern ETL tool, yeah, storing for staging, and you can use multiple clusters over the shared data, which is bringing the possibility actually to online scaling for which pools you will use and how the pools will be shared, how they will be used. And as I said, the multiple clusters could be SQL pools or could be Spark pools. Online scaling, another feature. Yeah, usually if you are processing any data in data warehouse, there are two stages. Yeah, one stage is once a week, once a month. You are actually loading the data and you are processing all the data from the backend system. And it is a huge workload on the hardware, etc. And secondly, there is the part for the rest of the week or rest of the month, where you are just reporting and actually do the analytic work above these data. So it's not so so there is no need for big workloads and big hardware in this time. And that's actually what online scaling is able to help you with. So you will be scaling, and I'm saying now automatically scaling, that in sometimes you will need more pools, you will be more compute resources. And after some period, 2 days, you will not need them, so you will switch them automatically off and you will use the rest. And it's very cost-effective way how to work it. There is also on-demand processing, that what means cluster and serverless. So you don't need the server to be provided somewhere. You can actually open the Azure Synapse Studio and work with that as it is. What I said, the Azure Synapse is built on the data lake, and that's mean the data lake is bringing the security, single access and security, and etc., etc. And as I said, there is the SQL database and SQL data warehouse part of it, and also the Spark tools. And Spark tools, it's integrated a runtime of Spark tools, and you can run them quite easily in Azure Synapse. What another nice feature which Azure Synapse is bringing is actually prioritizing the workloads for the resources. Yeah, usually you have some queue where queuing the requests for processing, and usually it's done first out and first in, first out basis. So if you actually process one, there is another in queue, and put it like this one, and it's working correctly. But if you have some, let's say, prior tasks in the queue and they are still waiting for the resources, then it could be a problem. With Synapse, you are actually able to prior these tasks in the queue. Yeah, you can see there how to actually do it in the coding. I know that it's just an example, and there will be much more problems in the organization. And I'm not saying the technical problem, but I'm talking about the business problem, because what is the priority number one for the company? CEO task for the database, or for example CFO task for the database? And there could be some organization constraint which could actually made it very difficult to set such a prioritization. But from the technical point of view, you are actually able to say, okay, this task is high priority, and then it will be queued as the first one, and it will be then processed as the first one, as there will be actually compute node to do that. Also, another feature is a little bit connected to that. It's like the organization isolation of some group. So, for example, you will say that the sales group and everybody in the sales group will use 60% of the resources, and the marketing will use just 40%. And that's actually how you are actually managing the usage of the resources through the firm and through the organizational chart. Another one which is actually connected to how much data you are able to process is the innovation that you actually have integrated the materialized view in it, which, as you know, are fast way how to get data processed. So, and Azure Synapse Studio is actually supporting this materials view as itself. If we will look at the Synapse Studio from the point of pricing, then we can say that it's 25% less expensive than Redshift, and more or less expensive than BigQuery. You can see a graph of the study where 30 terabytes was used and was processed, and you can see how actually the payment for that was done. Yeah. as you can see, comparing to Snowflake, to BigQuery, and Redshift. What is it actually also coming with Synapse is multiple level of security. Yeah? We can get, okay, there is data protection, access control, authentication, and the network security, which brings actually the data lake behind the Azure Synapse. What is new with the new the Azure Synapse is the threat protection, which was, the threat protection was promised several times for the SQL Server, and I'm not sure if there will be anytime the SQL Server will bring that threat protection on-prem, I mean. But on the Azure Synapse, on the cloud, you will get it with the service of Azure Synapse, let's say in one package. Okay, then we are talking about limitless. We are talking mainly about unlimited storing, which depends on you, and we are also talking about the limitless performance. Actually, there is limit of the pools you can use. Yeah, so you have 128 concurrent slots, which can be used simultaneously on a single data warehouse. But there is possibility actually to go beyond that if you actually create another data warehouse with another, let's say, 60 or whatever concurrent slots, and then you will get to the limitless performance. That's something which is also connected to pricing. Yeah, I just warn that if you actually click that you want so many slots, then the price will be higher than expected. And yeah, sorry, yeah. And what else you will see, and we will go through that after the lunch break, is actually the Azure Synapse Studio. Yeah, and as I said, Azure Synapse Studio is putting together all these services that then you have very easy way how to get all the main services you need from the data warehouse. That means ingestion, exploring the data, analyze the data, and visualization. Yeah, and we will talk about it later in the afternoon. If we will be talking about the Azure Synapse in practical view. So this screen I will show you in the afternoon, and I will actually forward the speech back to Martin, who will guide you through the Azure Data Factory as a part of ingestion in Azure. Martin, I will stop sharing my screen.
Yeah, I will start share my screen with Azure Data Factory. Yeah, it's one of our technical. It's one of the technical component in the solution we described earlier. And what is Data Factory in detail? So yeah, it's this part. So Azure Data Factory schedules and orchestrates data transformation in the modern data warehouse. So it could be used as ETL tool or ELT tool. So it's Spark-based platform. First, we should mention some organizations that fully harness their data outperform. So here's a one free references. One is Milan, which transform data from multiple sources to provide feature experience for clients. Second one is Lumex, focuses on the data itself rather than the logistic of ingestion. And the fourth one is Concentra, approaching the separate data sources with automated and scalable processes. Okay, what is Azure Data Factory? It's cloud-based data integration service that allows you to orchestrate and automate data movement and data transformation. So there are some important statements here. So it's cloud-based, so you cannot get your on-premise copy or on-premise installation. So it also allows you to create data-driven workflows for orchestration, data movement, and transforming at scale. So you can create and schedule your workflows. It's called pipelines. You can ingest data from disparate data sources through different connectors. There are many connectors. You can build complex ETL processes that transform data visually with data flows, or by using compute services such Azure HD Insight. You can use Azure Databricks. You can use Azure SQL Database. You can also use SQL Server integration services, cloud service for any of your needs. So it's a very complex, very advanced tool. Many of components from Azure Data Factory are shared with Synapse Analytics, so you can see some familiar things in Azure Data Factory, also in the Synapse. So Azure Data Factory, it's serverless, it's scalable, it's a hybrid data integration service. So it means it can use some gateways to get to your on-premise data. So it enables data movement and transformation at scale. So it's cloud and hybrid. There are more than 80 connectors to get your data. You can get your data into the cloud. There's a hybrid pipeline model. So it's seamlessly span on-premise, Azure, other clouds, software as a service, because it can be installed through gateway into your data center, but we are still using the cloud service. It can run on demand, scheduled, or event data availability. So it can be used in different usage scenario. There is also dimension of authoring and monitoring. So there are two perspectives or two dimensions. So you can design your workflows, and also you can use SDKs for other languages. There are also visual tools. And last important thing to mention is SSIS package execution. So it's not cheap, but if you need some solution for your legacy environment, so it's possible. You can lift existing SQL existing SQL Server ETL to Azure and use existing tools like SQL Server Management Studio and other related things which you are familiar to. Okay, about the integration runtime, Azure Data Factory ADF, it's focused on data movement, pipeline activity execution, and SSIS package execution, but it's not the main part. So you can see there's a artifact called pipeline, and you can run it through Azure Integration Runtime, which is integrated with cloud services and applications into your data. So you can see there also this. So you can see the command line or command interface, and you can run your on Azure, or you can use it as a control part for your on-premise self-hosted integration runtime, which can be used for on-premise execution. So there are two different scenarios how to use it. And here's just the small showcase how it looks in graphical design. So there's a it's no code data transformation at scale. So, but I would call it low code because you are designing main stems graphically, but you can also add your own execution code. So it's focused on building business logic and transformation data cleansing, transformation, aggregation, conversion. It's based on Spark execution. So there's a managed Spark cluster inside, and it also guarantees resilient data flows with ease. So here's just an example. Here's a one data source joined with tripwire. There's some aggregation. There's some write into the target, and it's same with tripwire. So you can see there's a special notation for join. But there are two data sources, two aggregations, three aggregations. Then there's a join, and you can use the join data to some local sync, or you can export your data. Three writes, two data sources, three aggregation, one join. So it's very easy, and the graphical notation, it's very intuitive to use. So you need only few moments to get into your hands. Here are some standard scenarios how to use Azure Data Factory. So here's one scenario is based on data ingestion. It could be used for data preparation, and it could be used in many different ways because you can use it out of scope of your data warehouse or your Azure Synapse Analytics environment. So this is just only the use cases related to the Synapse Data Analytics. So you can probably think that there are many business processes that have need to ingest data files, log files, for which you can use Azure Data Factory. So you can load flat files into Azure Data Lake Storage, which could then be sourced to the load process into data warehouse in Azure Synapse Analytics. So the connect and collect processing is key of Azure Data Factory copy activity. So it's specific task in ADF, which is very easy to configure and run. And you can find many information about these steps. So here, just to jump to the first scenario, it's this one ADF copy activity. So it means you are just connect and collect your data. So we are collecting data from the data source, and it runs through manage Spark cluster, and you are syncing the data into your Azure Data Lake store. It's the first example how to use Azure Data Factory, but you can use it for other tasks. Next diagram will show transform and enrich, because you can also use Azure Data Factory for data transformation enrichment. So it means you can use, for example, a SQL database. You can create some data transformation, including lookups, sorting, some additional columns, and push it into your data lake storage. So it's just the default setup, but I think you can also use direct enrichment into Synapse Analytics. But this way is recommended because there is a very fast connection between Synapse Analytics and Azure Data Lake Store, because Azure Synapse Analytics use also the same infrastructure as Data Lake Store. So it means in technical way, it's better to use the massive backbone which is used for Azure storages. So there is also there's this concept is called usually concept of data flow in documentation. Next slide. It's about there's a special component. It's called wrangling data flow. So you can also use Azure Data Factory as code-free data preparation at scale. So you can see that guy is familiar to do Power BI, and it's also the same style of data transformation. So we are transforming table, reduce rows, add columns, combine tables. And so if you are familiar to Power BI, it's very easy to wrangle your data through Azure Data Factory with wrangling data flow, which is now generally available. So when we started with this, when we first prepared this presentation, it was only in preview. Okay, benefits of mapping data flow. So it's code-free data transformation at scale. Perform data cleansing, transformation, and aggregation, enables to build resilient data flows in a code-free environment, enable you to focus on building business logic and data transformation instead of coding. So it's great benefit, and it means high efficiency of your data transformation tasks or data transformation task development. And underlying infrastructure is provisioned automatically with cloud scale via Spark execution, because you are defining your data flows and then you can run it through the Spark engine. So it's very easy and very easy scalable. Here's just only the small showcase how it can be used. I will show it later in detail, and this is just a showcase about how to add, for example, data flow. You must add some data flow parts and add your data source into your mapping data flow. And after adding your data source, you can continue with other transformations. So you can very easily use your interface to the Azure Data Factory. It's interface to data flow, so you can define your sources, because it's also here in data flows. You can include your other pipelines, so you can use it as you can. So you can create. You can also select other components. So you can see this also. This guy is web based, so we are editing your Azure Data Factory settings through your web browser. This is just another example. Important thing is the triggering. You can run your data flow immediately, or you can add some special trigger, which has many options to run or to start, because you can define the trigger by schedule. So it means you can define some start date, some recurrence every, for example, 1 minute. If you need something like near real-time processing for analytics, you can use some tumbling window. You can also use some event. Event could be, for example, some data ingestion into data lake store. Or you can also monitor your data pipelines. You can see there are some very I cannot call it simple because it's very effective monitoring console, when you can see all your running or failing pipelines, and with some run IDs, and you can check what happened. So there are variety methods how can be ADF pipeline executed. You can use triggers, you can run it on your own, or you can think about some other scenarios. Here are here's the short list of transformation options in mapping data flow. So you have predefined set of transformations which can be used. You can use unpivot, lookup, join window, derived column, sync. It's right. Altro, new branch, aggregate, pivot, filter, condition, split sort, exit, select, surrogate, and source, which is about the meaning. So you can use standard ETL features, and you can exit very efficiently. It's just the example how to add transformation. You can use this plus symbol in the environment. About Azure Data Factory processes, you can also the typical process of data ingestion. So it starts with connect and collect. So it means it's some kind of reading of the data set. So it's the first step. So you must define the connection, and then you can use your data source. Then you can continue with transform and enrich. So you must perform, Azure Data Factory performs call to external compute resource, or you can use Azure Data Factory integration runtime, or you can call, for example, machine learning service, or you can call SSIS if you need it. So you can also enrich your data with some additional analysis, and then you can publish your data. And also there's a monitoring, which is important. So there are 3 steps to run and 1 control step to monitor Azure Data Factory process. It's very simple, very easy to use. So it's about only, you need about, I think, like 2 hours to get some practice experience with Azure Data Factory, and start with some real working project, because it's real simple. Here's an example or just description of copy activity process, because it's based on the source, some connectivity, some integration runtime with some standard features like serialization, deserialization, compression, decompression, mapping. And there's also some connectivity to sync. So you, during the copy activity process, you are reading data from the data store, performs all needed technical steps. Then you perform your just the copy or some transformation, and then you sync your data into the store. You can also use copy activity to copy your data, and so you can use it also for files. And there's a set of support file formats. It's text, JSON, Avro, OCR, and Parquet. And you can also perform compression and decompression during the copy activities. So there are supported codecs, gzip, deflate, bzip to zip deflate, which can be used natively in the copy activity. So here's just the example of some more complex data flow. So it's very good monitoring and management, and very easy to use. Monitor pipeline and activity. You can monitor pipeline and activity runs. You can query runs with rich language. You can see how you can get from the interface operation lineage between parent-child pipelines. Azure Monitor integration, so there is a diagnostic logging, metrics and alerts and events, so you can use standard Azure monitoring, and you can also restate pipeline activities if you need. So it's very powerful. And I think it's one of the best features in Azure Data Factory. It's called templates. So there are some pre-built data integration solutions which are created as a template. So it means you can use, for example, template for copy data from Amazon S3 to Azure Data Lake Store, or copy data from Oracle to SQL Data Warehouse in the future, to Synapse Analytics directly if you need it. So it's some kind of wizard. You define only source, target, and some additional settings, and you can just run it very easy and very fast. About Azure Data Factory components, terminology, linked services. So it's, for example, Data Lake Store or Azure Databricks. Linked services are much like connection strings, which defines the connection information that needed for Data Factory to connect to external resources out of Azure Data Factory. Linked service defines the connection to the data source, and dataset represents the structure of the data, because there are linked services and datasets. There are two purposes for linked services in Data Factory. They represent data stores, and they also represent compute resources. So it means you can use them just for reading and writing, but also for computation. So, for example, to represent a compute resource that can host the execution of an activity, AG inside Hive activity runs on HD inside Hadoop cluster. Okay, so we need some data sets, as mentioned before, represent data structures within the data stores, which simply point or reference the data you want to use in your activities as inputs or outputs. So it means there is inputs, there is a data sets for in and out. Other important thing is activities. So it's processing step in pipeline. If you want to, for example, use copy activity to copy data from one data store to another data store, so it's activity. For example, another example is Hive activity. But if we are talking about Azure Data Factory, it's usually about pipelines. So here's a running activity. And together, activities are integrated into pipelines. So pipeline is set of, it could be pipeline is set of activities, so it's logical graph. Together, the activities in a pipeline perform a task. So for example, a pipeline can contain a group of activities that ingest data from Azure Blob storage and then runs a Hive query on HD inside cluster to partition the data. So the benefits of this that the pipeline allows you to manage the activities as a set instead of managing each one individually. So it's some kind of automation of a task and orchestration. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. And last important thing, it's triggers. Triggers represent the unit of processing that determines when a pipeline execution needs to be kicked off. So there are different types of triggers, as mentioned before. And if we are talking about pipelines, pipeline runs, it's also important thing. Pipeline runs means that pipeline run is an instance of pipeline execution. So pipeline runs are typically initiated by passing arguments to parameters that are defined in pipelines. The arguments can be passed manually or within the trigger definition. And there's also parameters. Parameters are key value pairs of read-only configuration, so you can use also parameters for your processing. So you can define, for example, some parameters, some variables, names for some procedures, etc. And datasets are strongly typed and reusable, but parameters are passed during the execution from run context that created by a trigger or pipeline. So activities can consume parameter values. Integration runtime. So it was mentioned before. There's also control flow. Control flow is an orchestration of pipeline activities that includes chaining activities in sequence, branching, defining parameters at the pipeline level, and passing arguments while invoking the pipeline on demand or from trigger. That also includes custom state passing and looping containers. There could be some, for example, some for each iterators. So that's about the terminology of Azure Data Factory. You can see there are only a few terms here. And if we are talking about some dependencies, there are datasets. Datasets are in or are coming from or to linked services. There are activities. They consume and produce data. They run on linked services, and there are also pipelines which somehow integrate activities into a logical objects. And pipelines are scheduled, monitored, and managed. So here's also some additional usage of Azure Data Factory. So you can also use Azure Data Factory as an integration platform for some data-driven apps. So you can use it for example, for ingestion of your data from for example, from your Synapse Analytics into Cosmo DB, which can be used as a database for your software as a service applications or other applications you need. Okay, so it was a high level about Azure Data Factory, and now it's time to say something about Power BI. So we should find and stop sharing. So the Power BI will be presented by Martin Zaruba, one of my colleagues, and I think he's the best expert in Power BI I know.
Okay, so, thanks, Martin. Can you see my screen?
Yeah, I can see your PowerPoint from that from presenting perspective.
With agenda, yeah, and this is the Power BI.
I can see also notes and next slide, and I see the different. I think I see that presenter view.
Okay.
Yeah, my name is Martin Zaruba. It's good to know.
So that's strange. Where is my stop sharing?
Stop sharing. Can we start it again and
Okay, now.
No.
Now I should see my browser with Power BI. Not yet?
I see nothing. I see only the standard Zoom webinar screen. Yeah, now it's something. Yeah, I can see now. I can see your Power BI.com/home. Good morning, Martin. Yeah, it's good for me, but it's not morning. It's midday.
Now I should see the agenda. Okay.
Okay. Perfect.
Okay, thanks. So hello everyone, my name is Martin Zaruba. I've been working for Adastra for almost 5 years as a data warehouse and business intelligence consultant. I specialized in Microsoft Data Platform, both on-premise and cloud. In the next 30 minutes, I would like to explain to you what Power BI is. So what is Power BI? One description from Microsoft says that Power BI is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. With Power BI, you can easily connect to a large number of different data sources. You can visualize and discover what's important and then share that with other colleagues. Power BI itself started as a self-service BI tool about 5 years ago, and it was the answer to the situation then that is relevant also in many companies even today. Now let's take a look at the situation in many medium and large companies. Most of these companies have been operating a data warehouse for many years. It consolidates data from many data sources and provides important information about company's performance. This sounds nice, but some data warehouse implementations fail to meet the expectations of business users. And here are some reasons why. The data warehouse is not sufficiently used. Some data could be missing. Data is not stored in suitable form for the business. Data is late. There can be a lot of problems with data. Development is not flexible to fast enough to fulfill the business expectations. Reports do not meet the user expectations. They could be slow. The content or visualization or functionality could be old-fashioned, and so on and so on. Often we could also see missing documentations like report catalog. Users don't know which reports are available, who maintain these reports, how to get to the reports, and so on and so on. These problems forced users to find new data sources, process the data, and manually create their own reports in tools they know and they have at their disposal. So it's usually Microsoft Excel, Microsoft Access, or other tools from other vendors. This situation is well illustrated by a study we did for one customer. The study included, among other things, answers to two basic questions. Question number one, what is the primary data source for reports? You can guess, surprisingly, most of data sources were sandboxes and not, or shadow databases, and not the official data warehouse. Question number two, what tools are used to create reports and how are these reports delivered to users? The main tool is very often Microsoft Excel, and delivery method with this customer was a file stored in a shared folder on the network or sent by the email. There was a lot of hidden effort and inefficiency and hidden problems with this approach. And this was just an example of situation with one client, but it's common to many others. And it was the situation that gave birth to self-service BI tools. So what is the self-service BI? Self-service BI is a set of tools, functions, and procedures that allow flexible and fast data exploration, pilot verification, ad hoc analysis, information sharing, etc., with minimal IT involvement. It allows connect to different data sources, transform data to required format, model data to one semantic layer, and then analyze and visualize data to a beautiful and report which can show what's going on with the business. And also it allows to share reports with the rest of the company, with your colleagues and other. Now let's take a look how Power BI covers the needs of self-service BI. Power BI started in Excel as Excel add-ins, Power Query, Power Pivot, Power View, Power Map. These add-ins are now part of the Excel. You don't have to download them as a separate programs and install. They are included in the current version of Excel. Some of them are enabled by default. Some of them you have to enable in the settings. Microsoft, years ago, Microsoft was in position that if he wanted to accelerate the innovation, it has to be development has to be independent of Excel and SharePoint, and this is why the Power BI desktop was created, and also Power BI service, mobile apps, and later report server as an independent tool with a very rapid development lifecycle to bring all new features as soon as possible to the business users. Now let's see where Power BI is today. When we look at the situation on the market for enterprise business intelligence platforms and recent market research, we can see that Microsoft has been positioned as a leader in Gartner Magic Quadrant for analytics and business intelligence platforms for the completeness of the vision and ability to execute. You can see it in red ellipses in the right top corner. Equally, another company, Forrester, has recognized Microsoft as a leader in Forrester Wave, Forrester Enterprise BI platform, for the highest score in strategy and market presence. The numbers published by the Microsoft are also impressive, and some of them are even hard to imagine. For instance, more than 20 petabytes of data is ingested into Power BI service every month. Power BI service hosts more than 30 million of reports and dashboards. More than 150,000 organizations worldwide use Power BI. Service itself is available in 43 languages in 40 data centers around the planet. An extensive community of users has developed around the product. There are more than 280 Power BI user groups in the world. Users have a strong influence on the future direction of the product. They published already 24,000 ideas, and a lot of these ideas were already implemented in the product. Power BI is now part of the Power Platform, which is a group of products that allows business users to create simple applications with Power Apps, automate activities with Power Automate, or create simple chatbots with Power Virtual Agents. All without or with minimal programming knowledge. These other programs, but are out of scope of today's presentation, so let's focus on Power BI. Power BI currently consists of the following main components. Power BI Desktop, it's a Windows desktop application to create reports. Power BI Service, it's an online software as a service product from Microsoft. It has a rich API, but most of the users know it by the famous URL, powerbi.com. Then we have mobile applications. Applications exist for Microsoft Windows, Apple iOS, and Google Android operating systems. Then we have Power BI Report Server. It's standalone software. It's installed on-premise and allow you publish Power BI reports to on-premise without necessity to use any cloud services. And the last component is Power BI Embedded. It's an online software as a service for embedding reports to applications. So if you develop some applications like CRM system or other kinds of system, and you need to visualize data from that system to interactive charts, you can use Power BI as a component that you can embed into your application. So you are not using Power BI Portal or Power BI Report Server, but the charts are part of your application. So you can use Power BI Embedded as a developer of that system. In addition to the main components, there are many development tools and infrastructure components. There are differences between on-premise and cloud versions of components. For example, Power BI Desktop for Report Server is separate applications, which is only partially compatible with the Power BI Desktop for the cloud. We can divide these development tools to 4 areas, report authoring tools. So as I said, we have Power BI Desktop in 2 separate versions, one for on-premise, another for cloud. We have Report Builder or Power BI Report Builder, which is a tool for creating another kind of reports, paginated reports. And we have Mobile Report Publisher, which is development tool for mobile reports. It's older technology which Microsoft acquired years ago, and it's available only on-premise. So these reporting tools are usually used by the report author. Then we have report portals, Power BI Report Server for on-premise installation, and Power BI Service, the cloud service. It's intended for the users, but can be also used by the authors, because you can create some parts of the solution also in the portal itself. Then we have mobile applications for users. It allows to view the reports on your mobile devices. And then we have special infrastructure components like on-premise data gateway, which is a special component installed and maintained by IT, and it allows Power BI Cloud Service to access on-premise data sources in your company. And then we have Power BI Embedded, which I mentioned before. In addition to Power BI components, there are other tools that are also used to develop reports or the solution, and also to manage and analyze the models. We have SQL Server Management Studio. It's a tool from Microsoft, and with this you can manage and analyze the databases, no matter if it's a relational database in SQL Server or it's in-memory database from Power BI or analysis services. We have SQL Server Data Tools, which is another name for Visual Studio with the installed add-in for business intelligence projects. Then we have some community tools which are very valuable because they allow you, for instance, DAX Studio allows you execute and analyze DAX queries, show easily the execution plans, and fine-tunes the calculations, and so on, and so optimize the model. Then we have Tabular Editor. It's another tool which gives you same functionality as SQL Server Data Tools, but it allows you doing some changes in more efficient way. And the last tool I want to mention is LMA Toolkit. It's open source tool to manage Power BI data sets, compare them, and deploy. The whole platform is constantly evolving. We are not waiting years for new version of the product as it was before. New versions of Power BI Cloud Service are released on a weekly basis. Power BI Desktop has usually a new version every month, and on-premise Power BI Report Server receives free big updates every year. You can see that it's very rapid life cycle, and Microsoft has somehow introduced new features. And regarding new features, we have two options. Preview features. Preview features are available from the beginning. They are automatically enabled to all users that use the newest version of the product, or these preview features could be disabled and they have to be enabled in the settings of the Power BI desktop or the Power BI portal. Then after some time, new features become generally available. It's called GA. And from that time, they are fully supported and they are the part of the product. Few words about licensing. Power BI has few options how to license its components. First is free license. All development tools like Power BI Desktop, SQL Server Management Studio, SQL Server Data Tools, mobile application, etc. All these tools are for free. You can download them from the Microsoft web pages or from the stores, from the Apple, from Google, and you don't pay anything for that. Then we have user-based licensing. It's Power BI Free and Power BI Pro. If you use Power BI Portal as a cloud service, you have to license all your users. You have two options: free license. With this license, user can log into the portal and has some very limited set of the features which are available to him. He can, for instance, publish his own reports to his personal workspace, but he cannot share the reports with the others. If he wants to share reports with others, he needs a Power BI Pro license. This is paid license. It's something like $10 per user per month. And with this license, he can create shared workspaces, publish a report to these workspaces, and share it with other users. But again, user in this mode, other users needs also Power BI Pro license to be able to go to the workspace or to be able to consume the shared reports from the report author. Recently, Microsoft announced a new user-based licensing license. It's called Power BI Premium per user, and it is something between Power BI Pro and Power BI Premium. It's currently not available publicly. You have to fill some form and apply for a preview. And then you can test it. I don't know when it will be generally available. I think it will be probably at the beginning of the next year, but we will see. Then we have capacity-based licensing. It's Power BI Premium, and we start from something like $5,000 per some computing reserved computing capacities in the cloud and storage, and you pay it per month. It has it has a lot of benefits. Benefits could be additional functionality, which is not available for the free or pro mode. Or if you have a lot of users, more than 5,000, these users can have only free license. But if the report is published to this premium capacity, users with free license can read these reports and interact with these reports. So if you have a lot of users and if you need additional functionalities, the premium capacity is necessary. Then we have Power BI Embedded, as I mentioned before. It's for applications. It starts from a few $100 per month per capacity. A lot of companies also used Benefit, which is included in Microsoft SQL Server Enterprise license with software assurance. And if you have this license, you can install Power BI Report Server on-premise and use it for unlimited number of users on-premise. It depends how many cores processor cores you bought for your Microsoft SQL Server, and if this cores and if this capacity can handle your amount of users. Some words about technological background. Power BI is built on X-Velocity in-memory analytic engine. Sometimes it's called Vertipack. It's in-memory column-oriented database. It means that all data is in memory in compressed format, and you can operate that X-Velocity engine with a new language called DAX. DAX is abbreviation of data analytics expressions with syntax very similar to Excel formulas. Because it's different technologies, you can take into account new modeling techniques, but they are based on relational methodology and well-known star schemas. The X-Velocity engine is part of many Microsoft products. We can name Microsoft Power BI Desktop, Microsoft Power Pivot in Microsoft Excel, SQL Server Analysis Services, Azure Analysis Services, Power BI Cloud Service. The technology itself has two ways how to access the data. The first one is X-Velocity engine. It means that copy of the data from the source is copied to the server and stored in memory analytical engine. So all user requests are fulfilled with this in-memory engine. Another option is direct query. And the direct query is means that data copy of the data is not in the Power BI itself. There is only metadata, and if user interacts with the reports, each click or each interaction is translated to the language of the data source. So for instance, if we have Oracle as a data source, and on top of Oracle we have Power BI model with direct query, in direct query mode, all clicks on slicers and filters in Power BI are translated to Oracle SQL, to PLSQL, sent to the backend Oracle database, and then Oracle returns the result, and it's visualized by the charts or visuals in the report. It has a lot of benefits. If you want to see the most recent data and you don't want to wait until the X-Velocity engine is filled with the data and processed, you can use this. So you have a lot of data. It's a good option. Disadvantage is that X-Velocity has a lot of time intelligence or analytical functions which are not possible to translate to query language, to SQL language. So there are some limits what you can use. And it's also important that if you plan a direct query, you need to be sure that the data source itself will be able to handle hundreds or tens of hundreds or thousands of user requests in the real time, and not forced to wait until the result is displayed in the report. Technology, X-Velocity technology has two engines, Formula Engine and Storage Engine. Formula Engine, single-threaded, you can write a complex expression in DAX language, and it generates the query plans for the storage engines where there are only simple expressions. It's have a multi-threaded engine, and it returns data to Formula Engine and then to report itself. Now let's take a look at a few selected solution architectures. The first one is on-premise architecture. It's a simplified schema where all BI components are on-premises. Data warehouse from Microsoft or from other vendor includes all necessary components like ETL, master data management, data quality management, and so on. On top of the data warehouse, you can use analysis services for your enterprise semantic model, and then you can create some reports on that model or directly on data warehouse and publish it to Power BI report server installed on premise. Another very common option is a hybrid architecture. In this case, you are not using Power BI report server on premise, but you are using Power BI portal in the cloud. But for some reason, you need to keep all your data on premise. So you need just to install on-premise data gateway, which allows the cloud service to communicate with all on-premise data sources. And in this case, it works in direct query mode. So if you create reports in Power BI, you build these reports on enterprise semantic model and analysis services, or use direct query to relational databases. And all interactions are routed through the on-premise gateway to the data source, and then the results are sent to the report in the cloud. but the detailed data and the big amount of data is stored on premise and is under your control. Another option is modern data warehouse architecture. You saw this schema before. It uses cloud components like Azure Data Factory, Azure Databricks, Azure Data Lake, and Microsoft MPP, Data Warehouse Service, Azure Synapse Analytics. On top of that relational data warehouse, you can build semantic model in Azure Analysis Services, and then use Power BI service as a portal for users, and where authors can publish reports and share with the rest of the company. Another option is also purely cloud architecture, but in this case, we are not using Azure Analysis Services. But Microsoft recently added the possibility to publish semantic model directly to Power BI premium dedicated capacity. So you can use that capacity instead of Azure Analysis Services. Power BI has several methods of performance optimizations for large data sets that you can use. Simply put, they are all based on intelligent caching. It depends on what information is required and in which layer of the whole solution it is available. The most common queries on highly aggregated data can be handled from the X-Velocity in-memory database. For more detail, the engine generates a query to the Synapse, where there are more options to quickly return the result. In Synapse, we have result cache, we have in-memory cache, SSD adaptive cache, materials view, and all these options can be automatically used to return the result to the report as soon as possible in a very short time. Microsoft also is adding constantly a lot of enterprise BI features. As I mentioned, you can use large data sets in Power BI Premium. You can use aggregations, XML endpoints, which allows you to publish your semantic model to the premium capacity. Another feature which is included in Power BI Premium is paginated reports. These are the traditional reports for paginated documents or for the tables where users don't require the interactions, but they are great to produce some documents like PDF, Word, PowerPoint, whatever, or just to browse the detailed records in the database. Microsoft is also adding data lineage and impact analysis to the product, development pipelines, which allows to easily compare and synchronize the workspaces. If you have dev, UAT, and prod workspaces for your enterprise solution, you can use these pipelines. You can also create transformations in the cloud. So you can use data flow for your ETL, and you can use common data model to access data sets in another data sources. You can also use some machine learning options Power BI itself use Azure Active Directory for identity and security, and you can also use other Microsoft Cloud services like Microsoft Information Protection and Cloud App Security to protect and monitor security of your whole solution. What was in preview and but is also available now is cooperation with Azure Synapse and Power BI. Part of the Power BI portal was integrated into Azure Synapse. The basic idea is stay in one integrated environment and not switch between different portals. So you don't have to switch between Synapse and Power BI portal. So you can view published report in Power BI Workspace directly in the Azure Synapse. You can also edit reports in Power BI Workspace directly in Azure Synapse. And when you save the change in the report, you can do it in the Synapse, and it's immediately available to the users. And that's all from the brief introduction of Power BI. It's a very broad topic with many use cases. If you have any question, please write them to a Q&A, and we'll try to answer them during the webinar. Now I'm asking my colleague Martin to present another topic, and if I remember, it should be Databricks and machine learning.
Okay, so I can share my screen after your stop sharing, or can try, yeah.
Just a few seconds.
You can stop your share screening.
Yeah.
Sharing screen. Okay, and
it's yours, Martin.
Okay, it's fully nice. Okay, Databricks and machine learning. It's last part of morning session, so it's not morning, but it was planning as a part of the morning session. In case you have any questions, you can use QA session, or you can use chat. So there are no bad questions, only questions too hard to respond. And let's focus on the last part. The last part is focused on Azure Databricks and machine learning, because Azure Databricks is a data science platform. What does it mean? It means many things. Because Azure Databricks is a technical framework for advanced analytics at Azure, and you can also use other cloud providers, but we are talking about Azure Databricks, so it's a Databricks in Azure. But if we can explain some other related terms, so it's artificial intelligence. So it's also a concept that it's any technique that enables computers to mimic human intelligence. It includes machine learning. Machine learning is a subset of AI that includes techniques that enables machine to improve a task with experience. So it includes special domain called deep learning. And deep learning is a subset of machine learning based on neural networks that permit a machine to train itself to perform a task. But machine learning also machine learning also can use some statistic models and other things. But in theory, it's like this diagram. On the right side, there is a description of technical framework of Azure Databricks. You can see there are people, there are applications, there are also some data stores. And Azure Databricks itself, it's about Databricks Workspace, Databricks Workflows, Databricks Runtime, so it means Enterprise Spark, Databricks IO, Databricks Serverless, and Databricks Enterprise Security, because it's everything about the Spark. And about the data science, because we defined Databricks as a data science platform. So it's a set of many steps which should somehow discover some secret knowledge in your data. So there are many definitions of data science. So it's the study of some generalizable extraction of knowledge from data. It's a getting of predictive or actionable insights from data, involve extracting, creating, and processing data to turn into business value. So Databricks is a tool. So it means the data science is a set of tasks and processes with some defined input and outputs. So so if you are using data science tool, it doesn't mean they are doing data science. So it's important distinguish between them. Also, there are some ideas that data science is something like big data. So big data is about volume, velocity, and variety, sometimes about value, with potential impact on business. So they are potentially expensive. You need a lot of skills to handle your big data because everything is flexible. Everything is too flexible, and you must properly build your solution to handle large volumes of data. But data science is focused on complexity of analysis and potential impact. In many ways, and it uses ranges of tools, smart algorithms. It's also difficult to implement. It's slow and complex because you must try many different things to get one working thing, and it's narrow focus on analysis. So they live together and they can use the same technical tools, but they have different objectives. So it means data science is a field that compromises of everything that is related to the data cleansing, preparation, and analysis. Big data is something that can be used to analyze insight, which can lead to the better decision and strategic moves. So it's more productized. So it means it's not so variable, and it has defined output. And data analytics. So it's also here is called on the picture is called data discovery. So it's data analytic involves automatic insight into certain data sets, as well as purposes of usage of queries and data aggregation process. So it's about the automation, about some daily routines, some common tasks. So you should, if you are thinking about some data analysis, you should think about these free streams, which have different. They can use the same technology stack, including synapse analytics, but they are differently focused in the delivery process, and they deliver different things, and in a little different ways. Some examples of application of data science. So you can use it for sensor data analysis. You can define or you can predict your buyer propensity. You can analyze social networks. So you can have so it's about the good friends and bad friends. Predictive maintenance for some technical fields. It's also good to have where my when my car will break. Search engine optimization, churn analysis. It's also about some predictions, nature resource exploration. So if you have some mining company, it's good to use this use case. Weather forecasting. It's if your business is somehow related to weather, and you need some prediction, for example, for some month, which will be in 1 year, 2 years, you can try predict it on some historical data. Healthcare outcomes, it's a very good application, but you need some kind of hospital for it. Fraud detection, it's a common case because you can use AI and machine learning to detect some suspicious behavior. License research, target advertising, network intrusion detection, it's also important case. Risk management, also you can measure your risks, internal risks, external risks of your customers, and smart meter monitoring. So you can use your Azure. You can use Azure Databricks or Azure Machine Learning to cover all these use cases. Some short description of Azure Machine Learning overview. It's additional service, so we can use Azure Databricks or Azure Machine Learning. So it's two services. Both are delivered by Microsoft, but they have different origins. So Databricks is from Databricks and Machine Learning is from Microsoft. Azure Machine Learning is fully managed service, so it's connected with other services. So it's very simple to drag and drop and connect interfaces for data acquisition and modeling. So it's best in the class. It can use best in class algorithms, R and Python. So you can access to sample experiments, tested algorithms, it can support your custom R scripts. And there is also support for more than 300 R packages. You can also deploy your Azure Machine Learning model as web service, so you can use it widely through your other services or other applications. So it's the one of the advantage of Azure Machine Learning. It's a little different than Azure Databricks, but they can be used for many same use cases. Here is just the example of Azure Machine Learning workflow. This workflow can be also used not only in Azure Machine Learning, but also in Azure Databricks. So there are two parts of that workflow. One is predictive analytics workflow, where you can start with definition of business problem, analyzing of data acquisition, data preparation, some predictive modeling. So it's iteration cycle. So it means that you must define more models and evaluate the best model for a purpose. And after evaluation, you can operationally model. And then you can use your model to enrich data and for visualization, leverage predictive insights and operational solutions. So it's the same for all machine learning products, and you should follow this this strategy. Okay, Microsoft Machine Learning at Azure. There are more services. Today we are focused on two leading components. So it's jewels in Azure. One is machine learning in Azure Synapse Analytics. So it's cloud-based analytics service with machine learning. Or other service is Azure Databricks. It's Spark-based analytics platform. So if you prefer to be more in SQL Server world, so you should prefer machine learning in Synapse. If you are more focused on big data and some data science, you should prefer Azure Databricks. But there are also other services in Azure. One is Azure Machine Learning. We will describe it in a while. There is also Azure Machine Learning Studio Classic. So it's a legacy service with original Microsoft Machine Learning. For some cognitive analytics, you can use Azure Cognitive Services. So it's a set of pre-built services with some pre-built models for example, vision processing or sound processing. And because you are using pre-built models, it's very easy integrated with others. You can also use Azure SQL Managed Instance Machine Learning Services. So it's machine learning with SQL. Also, you can use machine learning and AI with ONGs in Azure SQL Edge. So it's a service which should be used for IoT. And there is one specific virtual machine. So it's Azure Data Science Virtual Machine. So it's pre-built environment with everything inside your virtual machine, which is hosted by Azure. So we have many options, many possibilities. How to decide? One possibility to choose is Azure Databricks. So it's fast, easy, collaborative, Apache Spark-based analytics platform optimized for Azure. So it's designed in collaboration with founders of Apache Spark. It has one-click setup, streamlined workflows, interactive workspace that enables collaborations between data scientists, data engineers, and business analysts. It has also native integration with Azure Services, Power BI, SQL, Data Warehouse, Synapse, Blob Storage, Azure Data Factory, and many others. And it also has enterprise-grade Azure security, so it's an important feature of Azure Databricks because we are still talking about data, but data security is also important topic for many use cases. Some very short introduction to the Spark. If we are talking about Spark, you can think about Spark SQL because it's extension for interactive queries. We can think about Spark machine learning library for machine learning, Spark streaming, graphics, and all these languages and libraries are supported by Spark Core Engine, which is based on Yarn, Mesos, and Sentinel Scheduler. So Spark unifies batch processing, interactive SQL, real-time processing, machine learning, deep learning, and graph processing. That's the reason why there is something like Azure Databricks. Azure Databricks in detail, it's a set of mentioned components. So there is a collaborative workspace for data engineers, data scientists, and business analysts. But you can, from technical point of view, you can also think about multi-stage pipelines, job schedulers, notification, and logs. So it's the control plane. And for execution, you can use Databricks IO for data connection, Apache Spark, it's serverless. You can use the REST API, and everything it's hosted in Azure. So if we are talking about some analytics in Azure, you can use some tools from Azure Marketplace. It's one of option. One other options, if you want to solve it in different way than in Azure Databricks, you can use Azure HD Insight. Azure Databricks was mentioned, so it's one of possibility. And so it's a good combination of easy of use and reduce administration. But if you want to just to process your data with some not light but not so extensive data science and machine learning, you can also use Azure Data Lake Analytics. So you can see. So if you are thinking about some machine learning in Azure, you should think about Azure Data Lake Analytics or Synapse Analytics with machine learning extension, or about the Azure Databricks if you are more focused on some coding of your machine learning. Azure Databricks runtime for machine learning. So it's pre-installed packages for machine learning like TensorFlow, Keras, Horowot, and XGBoost. Pre-configured Horowot estimator for seamless integration with Horowot and Spark data frames. Support for GPU enables VM for specialized compute for your deep learning needs, because if you are using some deep learning, it's a good idea to use some kind of hardware acceleration with graphical cards. Yeah, multi-GPU training of deep neural networks, it's also fine. Unlock complex machine learning and deep learning scenario in few lines of code. So we can see some provisioning of new cluster, because in Databricks you have some workspace and there are some processing clusters. And if you want to run your scripts, you need some kind of cluster, and you can define different sizes of the cluster with because here's a version of Databricks. There are some drivers, and you can define some worker types with, and you can also define some dynamic pool of workers. So here's an example with a pool with 2 workers as a minimum, and 8 workers if you need more. So more workers means more money, but if you need performance, it's needed. Okay, here's an overview of Azure Databricks notebooks. Notebooks are a popular way to develop, run, and run Spark application. In Databricks, from my perspective, it's the main way how to develop something in Databricks. So you can important things, you can use it to run your code including data visualization, because I have created this. Here's an example with some SQL here. And you can create also some simple visualization of the result if you need it. And yeah, important thing, notebooks support fine-grained permissions. They can be securely shared with your colleagues for collaboration. Notebooks are well suited for prototyping and rapid development, so you can very easy prototype some different solution for the same problem. You can also mix different languages in your notebooks. Here's just the current set. So the main part, or just the main machine learning language is usually Python. So even if that notebook is not Python, so it's usually the default language. You can also use SQL. You can also use R. You can use Scala, because you are defining the language for your notebook. But with this command, you can switch the language for some part of your script. So you can see you can also use Scala, you can use Secure Shell, you can use also some file system utilities, and there is also some command for rendered markdown. Visualization are supported by Databricks. So it's supported by all notebooks. You can run it in a notebook in place. So here you can see, as mentioned, some PySpark SQL. Here's just the datagram, and you can show some kind of so it looks like some segmentation by age. So the visualization are written in HTML, so you can save the HTML and explore it later, or just to send to someone else. You can use Matplotlib, so it could be rendered as an image. So you can just right-click on it and download as an image. You can also change the plot type, and here are some examples. You can use bar, scatter, map, line, array, pie. Quantile, histograms, box plot, QQ plot, and pivot. So there are many options how to visualize your data in Azure Databricks. Just some notes for libraries. Libraries are containers to hold all your Python, R, JavaScript libraries. Libraries resides within workspace or folders. Libraries are created by importing the source code. So you must import libraries into your Databricks. After importing, libraries are immutable. We can be deleted or overwritten only. So it's important feature. You can customize installation of libraries via init script by writing custom Unix scripts. Libraries can be also managed by the library API. So you can automate, for example, some initiation of your Azure Databricks platform. So some short introduction into Spark machine learning. So it enables Spark distributed machine learning for large data set on Spark clusters. It offers a set of parallelized machine learning algorithms. It supports model selection. It supports Java, Scala, Python. Processing is based on data frames. So it's something like data set, but it's in memory. Spark MNet is already installed in Azure Databricks. Also, you can use libraries from third parties. ML Spark, so it's Microsoft Machine Learning Library for Spark. Lets you create some scalable machine learning models for large datasets. So it includes integration pipelines with Cognitive Toolkit and OpenCV, so you can ingress and process image data. You can featurize images and text using pre-trained deep learning models. You can train and score classification and regression models using implicit featurization. So here's just a short list of Spark ML algorithms. So you can see you can use naive Bayes, decision trees, Gaussian mixture, correlation, hypothesis testing, random data generation. So maybe jump to the next one. If you want to somehow use some algorithms, it's good to know which algorithm is the best for you. So here's something called Microsoft Azure Machine Learning Algorithm cheat sheet. So you can see there is a one central question: what do you want to do? So it's the first question you should state, and after the just some simple reply, you can start. So if I'm talking about, for example, predict values, so it's very common task. So it's usually about regression, and I can use, for example, linear regression if I want fast training and some kind of linear model. But in case I want something accurate, I have enough time for the training, I can use neural network regression because it takes hours to train neural network properly. So you can see there are many choices, but you can somehow start with this cheat sheet, or you can try it and learn what is best for your purpose. Okay. So we describe something about some internal parts of components or components of Databricks and how to compare Databricks with Synapse Analytics, because maybe you are confused that you can use them for the same use cases. So you are right, and it's true, you can use them. And if we can compare these two technologies, so if you prefer Spark, and if you are talking about some master differences, you can see that if you are talking about Spark, so Databricks has a better implementation of Spark because it's the original Spark from Databricks. In Synapse, you have open source Spark, so it's good enough for any standard use cases. Notebooks, you can also have some kind of notebooks. Databricks supports real-time co-authoring, so you can collaborate on your data science or machine learning or data analytics problems. There is also automated versioning in Databricks. And compared to Synapse, there's Interact Notebooks. There is a no real-time feature for collaboration, so you can share, but you cannot collaborate. There is a no automated versioning. If we can compare data lake access, there is no difference. Support for Delta Lake, it's Databricks Delta versus open source Delta Lake. Data warehousing, yeah, it's major difference. Don't use Databricks for data warehouse, so it's Spark-based notebook tool. So it's focused on Spark, data engines, machine learning flow, and machine learning. Or on the other side, if you want to build some data warehouse with interface tool with some simpler machine learning, so Synapse Analytics is fine for you. So because you can use traditional SQL engine and Spark engine, and if you are good in SQL engine and you are novice to Spark engine, it's better start with Synapse, and after some learning and training, you can continue Databricks. About the development, so you can use in case of Databricks, you can use Databricks UI, Databricks Connects, Visual Studio Code. Spark development is available in Synapse only through Synapse Studio, but it's still evolving, so it means it will change. Not study this domain for a while, so it's evolving and emerging style of doing things. Okay, one of my last slides before the lunch break, because lunch is also an important part of the day. So if I want to compare Databricks versus Synapse Analytics, there are 5 main use cases. So if I want to solve machine learning development, so I would use Databricks because it's much better for it's a real machine learning platform, data science platform. I can use Synapse Analytics, but it's not so perfect, it's limited, and it's it's more about data management than about data advanced analytics. For ad hoc data discovery, you can use both, because if you are more familiar to R and Python, so you should select Databricks. If you prefer SQL, you should select Science Analytics, but you can solve the same problems in very common way in both tools. About real-time transformation, Databricks, it's Spark, so Spark is running very fast in memory in real time. So it's Databricks should be your number one. Silent Analytics has also support for real-time use cases, but it's not so major like in Databricks. So if you need it, so you must wait or use Databricks. And there are also the main differences. It's about the SQL analysis and data warehousing. So it's all about the signups. Also, it's also same in domain of reporting and self-service. So you can see that if you want to deliver some traditional or self-service for some less techy savers, you should use Synapse Analytics, or you want to create some more enterprise solution with some automation and standard way, you should think about Synapse Analytics. But if you want to be more agile and use more data science techniques and methods, you should use Databricks. It's the main difference, because there are many cases which can be covered by both technologies, but you should select what you can handle and what is your preference. So you have some options. There are also some cases without options. Okay. During our morning session, we described some high-level overview of components which are needed for analytics in Azure. So we call it modern data warehouse, or we can call it also lakehouse. Now it's time for lunch. So thank you for your patience. And if there are no questions or some questions in chat, we will meet again at 1:30 after the lunch. It's 1, not Central European time, so it's because we run this session before the time change. So we will meet again at 1:30, and we will continue with some labs to show you how technologies work and how they are integrated together, because it's good to hear, but it's better to see it. So thank you for your time for this session, and I hope we will see you in 1 hour.
So welcome back to our session after the lunch. Uh, Hope you are here. I can see, yeah, okay. We will wait just 2 or 3 minutes, yeah, to start. So once again, welcome to the afternoon session. This will be much more practical session, and we will show you how actually to work with some of the tools in Azure. I hope you are able to see my screen from the Azure portal, and we will go through the signups. As I was talking in the morning about the signups, that it's putting together some services, and you can see all these in the signup studio. Unfortunately, I have tried several times the signup studio to run today, and it is not running on the Azure. So we will go through the slides which I prepare for the morning session. After that, just to see and just to taste what is actually in the signups. But how we will get to the signups, we will go through this training. So first of all, if we want to do to create some signups, first we need SQL Server. So SQL Server, if you are adding some SQL Server, you will see screen like that. Yeah, there is the subscription. There you will add actually the resource group which you want to the SQL Server would be, and there is the server name and location. Location is connected to how much will you pay actually for it, because it's different in different location are different prices, and of course you should choose the nearest to your physical location. And you are also adding the administration account. This is the account where you can actually with any SQL queries can connect to the SQL Server and work it as it with the SQL Server as it is. So you have to enter the admin password and etc. The next page is about networking. If you want to actually enable the networking rules and the firewall rules for the SQL Server. So if you are going and trying to connect to the SQL Server from outside, you should actually enable it. There are the additional setting that's just about the Defender and much more, adding much more security to that, and you can review and control. As you can see, actually, I have already created a SQL Server because sometimes it took a little bit time to create. It's not too much time. It's random from, I don't know, from tenths of second to 2 minutes, but to speed up the presentation and to continue each step by step, I created some of the instances before. So what you can see as you have created the SQL Server, you can see the resource group, where is it, and what are actually other possibilities to do with the SQL Server. Yeah, you have the activity log. So what was done with the with the SQL Server. You have the IAM, which is the access control. So who is able actually to enter the SQL Server, and you can add actually the roles for the SQL Server. Yeah, and if there are some problems, you have the diagnosis actually tool there. So this was the first step, creating the SQL Server. Second one will be actually creating the Synapse SQL pool. So if you write here, okay. Sometimes it takes a bit longer. And if you are creating the Synapse pool, that's mean SQL DVH, that's mean you will go through the same screen. So you are putting the resource group, you are putting the pool name, you are putting actually the SQL Server, and as we switch back to our SQL Server, which we have already created, you can easily get this creation of the SQL pool from the SQL Server. Just click on that and you are able to edit. Then some of these will be filled for you because it's connected to the SQL Server. What is most interesting on this page is the performance level, which is actually what you will get for the performance, and of course at the same time what will you pay for providing such a performance. Yeah, as you can see, the prices are differ from, I don't know, from one euro, something like that, till almost 400 euros. But be aware that it's for production hour, not for the day, it's for the hour. And you can see that what does it mean is this is the maximum and the limitless of the actually Synapse Studio and Synapse tool, because you can have almost 30,000 of DVU, which means it's I don't know if you know this measure. It's combining the memory, the performance of the chips, and of course the connectability to that. So it's a special measurement for all of these to get the highest performance as available. So just once be aware of this pricing. The pricing is per hour, and you have to know it. So, and if you want, you can same, if we will create a new one, new pool, there will be some availability, but we are creating from the SQL server. So that means some of the settings are already done. Additional setting is, if you would like to play with it, you can actually put some sample to be created or in your pool, some sample data already, so you can use them, yeah, or you can back up from some other source, and then you can review and create. As I said in a previous example, I've already created it, and you can see this is the actually Synapse SQL DVH. What is there? You can see the workload management. So how what is actually is done on this pool? Yeah, there you can set the maintenance schedule. It could be scheduled on automatic way. So every Sunday there will be some polls for automatic schedule and etc. You can get, of course, the connection string, how to actually connect to this pool, and etc. And if you actually are in the common task, you will see the things about what to do in the Azure pool. There is the loading of the data, yeah. And as we said in the morning, loading data, it's a part of Azure Data Factory today, but you can use it, and actually you are using the Data Factory incorporated encapsulate into the Synapse Studio query editor. Yeah, it's you can actually query the data as simple as you are querying in any SQL database. You can build the dashboard, and then you will switch actually to the Power BI, and you will build it on the BI platform. And if you actually go to the model and cache, then you are actually switching to Databricks, to the pools with Sparks, and you will create that. Actually, there are more things to you, but they are not so much interesting. What is another thing you have to create it and you have to connect it is definitely the data lake behind or under this Azure Studio, which is easily a storage account where you can use all your data or move your data, and then you can work with them. Yeah, without that, the Synapse Studio will not be working, as I said. But you can very easily switch it, turn it on, and it is. What I haven't shown you is the last and the most, let's say, from the point of cost to you, is the most important part of that. It's the pausing. You are actually able to pause, and I will do it. Pause the whole SQL pool. So you will switch it off as it is. If there will be some running, jobs, it will be asked if they should they should finish, and after that it will be pausing, or you will be pausing just now, and that's mean that all actually the jobs will be terminated. And as this task will be done, then there are no money actually. There is no cost running from the pool. So you have just some small amount of money for the SQL server, just because you are not using any resources from that. It's really small, and something from actually the storage account, but these numbers are really small. And hopefully we will see. Okay, it's running. That's why I actually prepare some of the things, but because it lasts sometimes in a range of minutes, and that's a problem. Yeah, but you can see that it's in the middle of the pausing, and there will be no connection, and it's paused, and no costs are running on that. The last thing which I was actually being prepared to show you was the Synapse Studio, and I was prepared to show you in the Azure itself, but as it is not working, so I will show you from the slides. So on the pool, you can get easily to the Synapse Studio, which is actually putting all these things together, and you can use the serverless function there. As I said, there are these, let's say, three main things. You can ingestion the data, you can explore and analyze the data. The ingestion should be the part of data factory, yeah? Just memorizing once again, yeah? Data factory. Exploring, analytical could be the data breaks, and visualization is the BI, Power BI. So if you go through the overview, through the Synapse Studio, you can see also the things you can do with the data. So you can develop, orchestrate, and monitor. If you see this screen, what will you say, what you can see? Actually, this is the data factory. You will see it after that with Martin's presentation, but this is the Azure data factory, and the screen and the buttons from there. What you can see actually is also do the SQL analytics on demand. That's what I said. That's the SQL, actually, serverless SQL. So you want to
Kuba,
some of the data from your database, and it could be done like that.
Kuba, can I ask one thing?
Yeah.
Are you showing slides or just a simple
Slides.
SQL server sample?
No. I'm showing slides.
Okay, I see only your Chrome or with sample Synapse SQL pool data.
Okay, sorry. So we'll try to.
Thanks.
Okay, can you see it now? Sorry.
Yeah, and I can see visualize your serverless query with the click.
Yeah, and Azure Synapse Studio. Sorry, so nobody interrupted me. So I will go back here. This is the Azure Synapse Studio which I show morning. There are the parts which you can use and you can do. Once again, if we go on, there is let's say the Azure Data Factory part, which is part of the Azure Synapse Studio as it is. And we were just now on this slide where you can see the serverless option, how to actually select the data and how to use SQL language to work with your data, which are actually in some storage on your Azure account. And that's all from my point. Sorry for that you haven't seen it on live. the Azure Synapse Studio, but you can try it with from the Microsoft portal and see how it is working. And it was quick, and I will pass the word to Martin back to show you some of the other tools in Azure.
Thanks. So I will start sharing my screen. After I will find the right one. Yeah, this one, because I have more presentation here for other sessions. So it's time to, okay, it's time to share. Okay, my demonstration or my demo will be about three things. It depends how we will count it, because I will show you some examples from blob storage, data lake storage, and data factory. So we will spend about 15 minutes with some demoing. I prepared few demos. One set is for Azure Data Lake Storage Generation 1 to show you how it worked and how it works, but it's now it's something not recommended to use. I will show some differences of Generation 2, and then I will try to show you also some work with Azure Explorer. I prepared my presentation as a video because I cannot speak and show something at once because I'm too simple for this type of task. So if you are looking for Data Lake Storage Generation 1, so it's Data Lake Storage Generation 1, and you can see some notice that you should use Generation 2, and it's now generally available. So it's important, so you can find it still in Azure Marketplace. We can check plans. It's time to create it. So it's important. You must put some service name here, some some good name. For example, Azure Adastra Data Lake 1. Okay, now it's deployment in progress, so we must wait for a while. So I've created this as video because to spare some time, because we have only 50 minutes for these two interesting sets of technologies. So now we can see few refreshes, and we will see new created data lake in a while. Yeah, it takes some time. And you can see my nervous clicking to refresh button because it's not it's different, because the Generation 1 was relatively slow, and now we can see some announcement that resource was successfully deployed, but there is a problem or just some latency in console, so it's better to go directly to the resource, or I must refresh my console properly. So now you can see I've created my first data lake. So it's magic. Now it's about creation. Okay, it's again the same. I have problem with this place. Okay, let's see our first data lake. Okay, there's a console. You can see activity log, some spend. I can define some access control policies. I can add additional text. I can also diagnose and solve problems. So it's standard like other Azure services. There's also reporting of events, but my data lake is fresh, so there's nothing to see. So there's no, and there was missing support for events that in that selected region. And I can also select some different or monitor price tiers. I can define some additional properties. I can define some logs. I can export template for my Azure Data Lake, but as you remember, so I put only the name and some basic setup without any additional settings. And you can see also diagnostic and settings here. So I can diagnose many things. And there's also a resource of monitoring. So my data lake is healthy, so I have healthy data lake. Okay, you can also create a support request from the console. So it's also integrated into. Okay, just one simple example. It's how to upload file into generation 1. So here's a data explorer. So it's tool to work with your files in your data lake through your web console. So I can upload data into my lake. So it's only about to select them. So there's a one screen missing here. So I've edited the file and file is uploaded. Because we are working with distributed service, so we should wait for some announcement. So you can see the upload is in the process, and we cannot still see the file in the console. So I can try it open again for some direct refresh, but it's about some asynchronous processing between the storage layer and the access layer or the monitor level. So still nothing here. So I can try different refresh. You can see there's a missing button for refresh, but I've already uploaded the file. So after next open, you can see my CSV file with wine codes for some cars. Okay. Generation 1 also supported preview of the file, but only for a limited set of rows. So my file is much longer than this one. I can also use you can also use Azure Storage Explorer, so it's tool provided by Microsoft for Azure Blob Storage and for Azure Data Lake Generation 1. And because Generation 2 is just some overlay over Blob Storage, it can be also used for Generation 2. Okay, this one I prefer. Yeah, Generation 2. Generation 2 is more interesting. It should be cheaper, it should be faster, it should be better in all ways. You can see it's a little confusing to find it because it's just setting, it's specific setting of storage account. So you can see there's some introduction to the service, and we can write new name for my new data lake. So it will be data lake 002 in West Europe. I can go to the US, so it's no problem. I can select performance level. I can select storage kind. I can also define redundancy, so I can be the best friend of my users. And I can also check other additional settings. So yeah, and there's the most important setting, data lake generation 2 button, and you must enable the data lake generation 2 on your storage account. Now it's provisioning, so it takes some time. So we can jump ahead. Yeah. So the deployment is underway, and we are waiting to create our new water gun for our nice data lake. and you can see the console is more rich or more complex than in case of data generation 1. So generation is over, and here's a guy interface. So you can see, you can still check activity log, you can define security for access, you can diagnose and solve problems. You can also somehow evaluate your data transfer with some recommendation. So you can see, so I want to upload 50 gigs with some repeatedly, and there are many options which I can use. That could be Azure Storage Explorer, Azure Storage REST API, or file sync. There are also some report of events. So there are new events because it's fresh new lake with fresh water inside. And you can also see access key, which can be used by third-party applications, georeplication. Now my data lake is stored on the west and east coast of United States. Here's a HTTP feature called course, configuration. You can also see I can change setting. Here's a shared access signature, so I can define additional secure rules. There's also some definition of private endpoints, advanced security. So you can see there are many security options here. I can also use my data lake as a static website because I can put files there and it can be presented as static HTML. There are also other properties. There are also logs, and I also export template. And you see, it's more complex than in case of generation 1. And here are containers. There's a lifecycle manager because I can also manage my data by rules. There is also the storage for tables, so it's no SQL database for queues. And there's also monitoring. I think that this monitoring is already generally available, so it was new during the summer when I prepared this set of presentations. And you can see there are many measures, alerts, metrics. I can also use workbooks, but now I'm trying to get some information about payment. Here are some metrics, so I can measure availability, capacity. So now everything is perfect and everything works fine. And here's a workbook, so I can create some overviews, storage account overview, performance overview, maneuvers. There's also some advices for my data lake, for example, some checks of security rules. Here are some metrics from classic view. Diagnostic and usage of classic data in classic view. There's also resource of monitor, connectivity check, and new support of generation. Yeah, let's see Storage Explorer. Because you can access your data with PowerShell, so here is just very good documentation which can be used to manage your data lake. So you can use your command line. So here are some examples and some samples of how to use it. Okay, let's see Storage Explorer. So now you can see, so it's preview, but I think now it's generally available, so it's no problem. And new features are added every few weeks. So we can see I have containers. So containers means lakes in this case, logical lakes, queues, and tables. So I have 4 types of data stores, and there's nothing inside, so I can see it. So for some edit, I need some additional tools. Okay, I can create file system. So I will create my files 001. So my first container is created. So it's folder on my data lake. And I can create new folder with name sales 2020. Nothing inside, so now I think now it's available. So in this case, we can use AZ copy or Azure Storage Explorer. But I think that this feature was already added to them. But it's the same like generation 1. Okay, now let's investigate Azure Storage Explorer. So it's this desktop application. You can see I can attach my data lake store. You can see the same blob containers. There are no file shares, no queues, no tables, with exception of some metrics in my lake. And here's my data lake generation 1. Because as mentioned, this tool can be used with generation 1, generation 2, and with blob storage because they share many technology parts. There is no reason to have 3 tools instead of one solving one problem. And as you can see, so here's my container, my file 001 and my sales 2020, and I can upload my files. So it will take some while, and there's also one additional window with selection missing. So after magic happen, so you can see that I uploaded 2 CSV files with reports for March and May in CSV files. Yeah, these files will be used also during my Azure Data Factory presentation. Okay, other example, last thing about one of my last notes is existence of stores, keys, secret keys, access keys, which can be stored by third parties application or by other services in your data lake. Okay, now it's time for Data Factory. So it will take me about 30 minutes. So I promise I will be fast, but not fast enough. So how to start with Azure Data Factory? Open Marketplace and look for some factory. So it's Data Factory, not Meat Factory. So we can see some nice screen, some overview, and it's time to run create. So it could be so it's time to define some name for my Data Factory. Define some good zone USEs because my data lake is already located there. So I disabled also the Git versioning, and now there was submit of deployment, and deployment is in progress. Okay, so we can go to the resource. So it's standard Azure service, which can be monitored, but I'm the most interested in that web console for Azure Data Factory because this one is only the monitoring console. It's not that console mentioned during the morning session. So you can see it's standard console in Azure, which are available for each service. Now we can switch to metrics, diagnostic setting, and resource health. Okay, so now it's the time to show you about the main Azure Data Factory console. So it's hidden here, author and monitor. it's important reference. So you can see starting new web application, which is something like Data Factory Studio, but I'm not sure about the name now. You can see that it's a full scope web application with some welcome page with reference, and you can see there are two sub application or components. One is for authoring or for author, so it means somebody kind of designer, and monitor for some execution of your workflows and pipelines, data flows and pipelines. Yeah, here are some tutorials. There are some notes about updates, and now we can go through the console. Here is just the authoring or author designer. I can also import some templates, and monitor is very simple, and there's nothing to see here, so we can see nothing in my dashboard. No running pipelines, no pipelines, no triggers, no integration runtimes, except the auto resolve integration item. So it's that provisioned Spark cluster. And okay, working with templates because it's only them. Okay. As you can see, there are two. Well, there's a one linked service here, so it's my Azure SQL database, which I created before to show you how to move data in Azure Data Factory. And there's also my Azure Data Lake Storage 1, but it's generation 2, so it means it's the second data lake, not the first one. And now we can look for templates. You can see there are many templates, how to move data, it's a copy activity, templates usually for copy activity. So you can move your data between many different data sources just through Azure Data Factory. It's not only about the signups. And you can also see that there's a very simple setting so I can start with some getting files from my Azure Data Lake storage, and I want to put them into my SQL server, which is serverless SQL server. So it was in some kind of prototype, so it was sluggy during demoing, but now that service works fine. So you can see the definition of my pipeline. It's bulk copy from files to database. For each file, there is some kind of subtask where it ran, and we can query my SQL Server database through my through my other web console. So we can also, yeah, there was fail, so it's time to see why. Here's a message with some error code, and there's some, we cannot locate the file. My file is 001 under the storage account, so it's time to fix it. What was the problem? The problem was because I must define source container name and proper name of source directory. Without it, Azure Data Factory is lost and cannot process my data in defined way. So I can now try run it again. It's running, it's copying data. It's now in progress because the provisioning or just allocation of the Spark cluster takes some time, so it's not immediate action. Now it succeeds. Fine, so everybody is happy except me, and we can see my new tables. So we can see I have two tables. it's just pure copy of my CSV files. Yeah, it's important to run it. And you can see there are some data inside. So it's also with the header from CSV file. So because it's for the setting in bulk copy activity, so you can improve it if you need it. So, but I've selected this strategy just for demonstration. And now it's time for next slide. So let's get to the detail. So you can see there are some mentioned parameters and variables. So here are some variables. They are defined through parameters. Here is also setting from for activities. So it's composite activities. So it means there are some other activities inside. So I can drill down, and you can see there is a copy activity, copy files. And here's a definition of the source. It means which file name. So it's also variable from which source, from which directory. So I can create very complex solution because I can script it through parameters and variables. There is also target sync. So I can enable auto create table, or I can create some simple mapping. So because copy activities is not only about the pure copy, but you can also define some additional mapping if you need it. But it's not data movement, it's data movement with transformation in that case. So let's see, my data pipeline is also defined by code, and this code is versioned in Git. So you can see there is a human readable definition of my clicking in that application, and I can use it as a definition of my transformation. And there's also some limit possibilities to edit it. So you can, for example, change name of the table, but you cannot develop it through the structure of the JSON because it's tightly related to the interface. Not to the interface, but to the graphical user interface. Okay, so now I validated my solution, and we can go further. So let's see pipeline guy. Yeah, because if I want to somehow, yeah, there are some difference. If I want to walk through data pipeline editor, you can see there are many types of operations, usually integration with other technologies, for example, execute pipeline or some kind of webhook. There are also special tasks for HD Insight. I can also perform some filtering, some iterations, some integration with machine learning. So it's very powerful, and I can create very complex logic just through clicking and adding new artifacts. Okay. Okay, here is just how to create a new trigger. So we can see there are many settings, but I'm not sure if I don't miss triggers. Okay. So you can see triggers. I can define if event, for example, for my subscription, and could be this definition of some event. So if I can select some container, so it's pre-filled for me, and I can define some event, blob created, blob deleted, ignore empty blobs, some annotation, and if it's active or not. So it's just example how to define trigger driven by events on my data lake. And I can also leave it based on time window. Okay. let's check trigger. Start it. And it's not, yeah, it's not immediate action, so we must wait for a while. Okay, so yeah, okay, my trigger seems to be working, and I can also add the trigger to my pipeline. And here's a trigger one. It's a bad idea to use default names, but yeah, here's just the setup for the trigger. So I can publish it without proper setting, and you can see there are some errors because I cannot deploy configuration without proper setup, because I omit parameters for my setting. I must add values here because it's context of the trigger, and trigger must push values into the pipeline to fill all variables and to perform all actions. Okay, publishing again. Okay, so magic happened, and it was about publishing. About the monitoring, yeah, we can monitor run. So there is some scheduled run. So I have one pipeline which depends on trigger one. So trigger seems to be successful. So trigger is running, and there is some planned trigger time, and we are waiting for something happen. Yeah. So we showed that it ran at least twice. So yeah, here's just the report of the trigger with some trigger time, and yeah, you can see that there are properties here for trigger time and schedule time, and we also check again our database. So yeah, it's a 1 minute window, so it's a little tricky to find a certain point in time to show. Okay, here are also triggers in outro, so I can also run it immediately. Yeah, you can see it was defined for 1 minute. So no fear about processing of my trigger. And now we can see some two succeeded pipelines run through triggers. So it works. Okay. Another important task is copy data. It's some embedded wizard, so I can select only through the wizard. It's not so detailed as templates, but you can see I will select some services, so I will create opposite direction. So it means I will copy my data from my SQL server to my lake. So it's infinite loop of data in nature. And next, destination, I will define some target path. Okay, I will create some names. Yeah, I will improve. Yeah, it's fine because Now there's some compression, some other settings. Here's some summary, and we can deploy it. Because you can see creating data sets, creating pipelines, running pipelines, and we can switch to monitor. And my copy pipeline is in progress. And we can continue with the file check. Yeah, it's my Azure Storage Explorer again. Here's my files, and you can see there are new files here because originally we used the folder sales 2020, and now I have new copy. So it was data ingested into from the lake, ingested into SQL Server, and then back from the SQL Server to the data lake. So it's very easy, and you can perform it in a few minutes if you know how to do it. And another important thing is about the data flow. It's one of my largest presentations from Data Factory, because it's about how to work with data flows. So you can see it's my new data flow 1, and here's how to create some simple transformation. There's also some tips how to use it. So I will select my data set. So yeah, I should add a new data set. You can select. I can select many different data sources. For example, in my case, Azure SQL database. I can select linked service 1. I have 2 tables here, and yeah, it's here. Okay, and other new data sets. It will be the second table. So it's good to switch to Azure SQL database. And now it's the second table for May. And now my datasets are prepared. So I can continue. Yeah, error is away. And now we can test connection. So the testing connection seems to be a little lazy, but it's about some allocation of the Spark cluster to check the connection. So it's not perfect for this simple operation, but I'm sure that it's working. And now I can select the proper operation. So for me, I think the best one is union. And I can also add second data source. I can select table 2. Okay, so now union is prepared. Okay, and now let's try some data preview. So I can also try refresh, but it's refresh which is based on some execution of Spark engine. So it means the Spark engine must read data from my 2 tables in my database, put them together in that engine, and then put the result into my console. Because it's optimized for large volume processing, it seems to be slow, but it's very fast in case of large data volumes. And you can also see there's a code of my transformation here. And we can think what to do next. So we should somehow store our data. So we need sync. So it's a good idea to store our result because it's not a tool for data visualization or data discovery. It's tool for data integration. So where to store it? Okay, we should prepare some new table. Here's my table called sales data. So succeeded. My tables are here, so including the new one. And now I can add new data set. This data set will be target for my data transformation. And I can select linked service one, the new table, you can see it here, so it's refreshed. And okay. And we can continue. Yeah, we can select, just check the schema, general properties. So table 3. Yeah, we can validate it, but we must wait for connection testing. So it's again, because it's serverless, so it takes some time because it's serverless for large data processing. And now we can see our definition of our data flow. Now we are ready. So how to run it? So it's a very good question. So we must somehow, because this one is just transformation without any context, and we must create a new pipeline to host data flow. So pipeline is something like workflow, and data flow is just transformation. So it's very simple concept, and I can add existing data flow here. I will push OK, and I can run my data flow just directly from console. So you can see here's my transformation. Again, I can click through it. So it's very easy to understand what will happen. I must check some parameters, some properties, and now we can run it, trigger debug. So it means it's some kind of testing. So it's manual launch because it should be triggered manually or full triggers. So now it's in progress. We should wait for a while for data processing. So it's not so funny way because it takes some time to activate our serverless Spark cluster. So it's good to create some more complex data transformation with more steps, because you will get the same time spent with much more data transformations. This because in case of this simple transformation, we are still waiting for some minimal time spent, which must be spent to get to manage all overheads with the processing count. Now it seems to be finished. Okay. Okay, let's check it. So my simple task took 47 seconds. So I guess 46 was overhead and 1 second was for processing. But I have very small solutions, and my database is also serverless. So it's serverless with serverless. So I think it's also good experiment. And now I can try to check my data in my aggregated table, and you can see I copied 2 files into one table, or I've copied two tables into one table. Okay. So yeah, we can also check data flow again. Nothing changed here. Here also we only check of the connection. So yeah, it's that from 2004. And you can also open connection. It's 2005, 2020. Sorry. And it's finished. Okay. About the check of the data flow. So we finished our task, so we can run it again. And we can also check our result, but yeah. So we were successful with our data pipelines and data flows. Now we can try data wrangling. So it's different dimension. So we can add data sources. We have some registered tables here. Okay. I will use this sync data set. So it was my, okay. And I also add additional data source and some other. Okay, I have, it's my new wrangling data flow. So it's now loading data into my wrangling window. Okay. Okay, you can see, if you are familiar to Power BI, you can see very common style of how to process your data. So I can transform data, I can add columns with some additional functions. I can use advanced editor. So it's also script table. And I can use, for example, my transformations from Power BI here instead of standard data flow. Okay, let's check data stores. So let's add new data store. So there are plenty options to select. So we can select not only Azure SQL databases before, we can use Synapse Analytics. So it was just the below. We can also use some more exotic technologies. For example, Amazon S3. So it's possible to integrate Data Factory with some solutions in AWS. Support for NoSQL databases, support for other applications, including Salesforce, C4C, or Xero. So there are plenty of options, and it's good to know about it. And just a very simple example how to use SSIS, because for SSIS in Azure Data Factory you need integration runtime, so you must provision some cluster or just some machine running your SSIS. So I've selected this one. Here's some security details about my admin username and my password. Okay, my secret password. Test connection. You can also create package stores to manage your packages that are deployed into file system Azure, so it's possible. You can see I should define it with new, but I have no time for it. Here's just the setting for parallel execution, and now I can create my integration runtime. Okay, now I have two integration runtimes. One is for its auto runtime, auto restart integration runtime based on Spark. It's running, and I have second integration runtime for SSIS. So we can see. So it's the way how to use your SSIS packages in Azure Data Factory in detail, because you can use standard tools like SQL Server Management Studio and others, the data tools, to use it as before for instead of a standard Azure Data Factory. So it's starting, refreshing, and it's almost finished. Okay, so SSI packages. You can also look into your SSIS in deeper detail. Here's just some simple console which allows me to monitor my integration runtimes, and I can also check because I want to see what is happening in my SSIS. So there's also SSIS DB server endpoint, which is dedicated to my SSIS. So that's all about SSIS in detail, because it's more about some hands-on and experience, and about some migration of legacy solutions. Okay, so that was everything from my side about blob storage and Azure Data Factory. And next topic is Power BI. So I should stop my sharing. And Martin Zaruba, can you start with your Power BI demonstration?
Yes, I'm ready. Just a second. I need to switch my screen now.
Okay, we can check it again.
Test presentation. Share screen. So now you should see it.
Yeah, I can see a lot for Power BI, so
yes,
it needs to be working.
Okay.
Thanks.
In this lab, I prepared 3 simple demos. First one is how Power BI looks like from the end user perspective. Second, from the business analyst who wants to create some new report. And the third demo is from perspective of Power BI developer who participates on development of enterprise semantic model. Let's start with the first one. The situation is following. End user wants to use reports that were created by his colleagues or by the BI team. The only tool he needs is web browser, because the report is published to the Power BI Cloud Service to shared capacity. He needs Power BI Pro license. In my case, the reporting solution looks like that I'm using Power BI Cloud Service with on-premise enterprise semantic model in analysis services connected with Power BI Enterprise Gateway. The connection mode is live query, and the model has row-level security defined. And I will show you how it works. So let's switch to the browser. Let's start with this one. Right now, I'm logged into Power BI portal. It's called powerbi.com, and application is already there. What I can do, I can go to apps and click at the tile with the name of the application. Application is called Sample Sales Report. As you can see, it's interactive. You can see sales. The total sales are something like 54 million with the growth 8%. You can see sales by the sales province, and everything is interactive. You can filter this report by the territory or calendar year. And you can see how numbers in these years and territories. So you can see everything is interactive and very easy. Yeah. Right now, I'm connected with a user with administrative privilege. So I can see all the data. I can see all territories, all years. There is no limit with this. Now I will show you how it looks like with user with lower privilege. So I can go to another browser window, which I prepared in advance. So I can go to so many windows here. I can go to this one. And in this window, I'm logging as another user, as a Peter, who has also access to this sales report. So you can click at the tile. But in his case, you can see not 54 million total sales for year 2015, but only 14 million. And it's because user has access only to selected territories, not to all territories, but only to Far West and Mid East territories. But as you can see, it's still same the report, but it's limited in the backend by the rules of the row-level security, which says that this user can only see these territories. Very easy. User don't know about this. User cannot change it. This logic, it's not possible to delete any filter in the report. It's defined in the semantic model. What happens if the same report will be viewed by a user who has no access rights to this data? Let's switch to another browser. This one, I'm here as another Martin. I can go to the report, click on the report. And you can see there is no error message, but user has no territories and we see no data in the charts, no values. So this is how the row-level security works, and everything is defined by the model author, typically BI team in the company who creates the model. So this is the first very easy demo. So let's go to another. Demo number 2. This is from the perspective of business analyst. In this scenario, business analyst wants to create a report based on data in a data warehouse, enterprise semantic model, and share it with others. In this case, business analyst needs Power BI desktop to connect to the model, create a report, publish it to the workspace, and share with others. To do this, he needs Power BI Pro license, and also the readers or the end users needs Power BI Pro license. So let's go to the Power BI desktop. I'm in Power BI desktop right now. This desktop is not connected to any model, so we have to connect to the existing model. So in this case, I'm using analysis services. It asks me for a connection string to the server. So let me find it and paste it. I'm using live connection, so all data stays in the model. Nothing is copied to the Power BI desktop, and I click connect. At this server, I have access to two databases. For my demo, we need this one. And you can see that now I'm connected to the model. You can see that there are some tables and measures prepared by the BI team. I can also see how the model looks like. It looks like this. It's the simple star schema or snowflake schema with one fact table and some dimensions around. Let's create a new report. You can see that here is the browser which shows me all objects and columns in the model. And here are the standard visualizations available from in the Power BI desktop. So I can start with this line chart. I click at the icon, it's automatically inserted to the canvas. So I can now configure this visual. So for the, let's say you can show some months from the months dimensions. So we can use short month as axis. We can show metric called sales. Now we can see the sales per calendar month, but in this case we can see sales for the whole history, for the all years. So it would be better to add a slicer here. And no, we can do something else. We can use calendar year from the tie dimension, calendar year, and put it to the legend. So right now we can see year over year sales for each year is represented by different color. We can do simple customization. We can, for instance, move the legend from top to the right, so it's available here, or to the right center. Okay. And we can use slicer for something else. We can use slicer for sales territories. So we want to switch between sales territories. So I added slicer, and you can see that immediately when I'm clicking at the slicer, everything is connected in the model. So the filtering works. And you can see year over year sales in the for that region. We can also change the name of the chart. We can change it to something else, like for instance, sales. Now you can add another visual. For instance, you can use this matrix. It's equivalent of pivot table in Excel if you work with the Excel. And with metrics, we can add something else. For instance, you can use employee and put it to rows. In this case, let's show sales quantity. And we can show it again by the calendar year. So from the date, I can select calendar year, put it to the columns. So you can see sales for each employee over the time. We can also add another slicer. So let's add another, and you can do something else. For instance, city. So with this slicer, you can then filter sales by the city, but I'm using some sample database, so maybe city is not the right column. It's not populated, so we can use something else. We can use state province, I think. Yeah, so now we can see province from the far west territory, and again, we can use it for switching and filtering the charts. We can also add some other type of chart, like donut chart. We can use again sales and I don't know, something from customers in this case. Let's try customer category. And we can see that the sales, most of the sales were through the novelty shop and the rest is uncategorized. And because it's good practice to give the report some name, we can also insert some text box with the name of the report. You can put it here and call it, for instance, sales performance. And change the size of the font to this. So now we have simple example of very simple report. Okay, let's save it. Okay, and now we need to publish it to the Power BI portal. So easiest way is to click to the publish button, select appropriate workspace. In my case, it's analytic in a day demos, and publish it to the Power BI. Okay, it's there. So now I can switch to the browser. And go back. And what's going on? Right now I'm end user and I'm using this application, but application it was not updated. It's in its previous version. So the last step, what a report author should do, is to share the report with the users. So let's get back, let's switch to the workspace. And here you can see that here is the new report, which I published from the Power BI desktop. It's called Sales Performance. And you can see that it immediately works. Everything is here, same is in Power BI desktop. But I don't want to share this report alone. I want to share it in a package called application. So when I go to the Power BI workspace, I can include this app in the application. And when I click to update app. I don't need to change anything else. I can see that inside my apps there are 2 reports, and it's shared with the whole organization. I can click update, and I can copy that link and send it to the users if it's a new application, but in my case, it's the update of the existing application. And in this case, you can see that application has this navigation panel, and it has original report and the new report. So from now, it should be available to the users. So I can switch to different browser. Where is it here? Go back, go to apps, open the app. And as an end user, I can see that this is the new version of the application, but of course, this user has limited sales territories. So if it goes to the new report, this was defined in the modal. So it's again applied here in the new report. And you can see that in this case, user can see data only from these territories. Okay, so in this demo, you could see that it's very easy to create a new report, that the business analyst don't need any special skills if he works on top of the existing semantic model. He needs just to know how to work with the Power BI desktop, how use visuals in the Power BI desktop, and everything else is already prepared by the BI team. And publishing is also very easy. It's enough just to click publish button and then update the application, check if everything works on the cloud in the workspace, and then share, edit to the pack of reports intended for that business department by updating the application. So that's all. So let's switch to the last demo. And in this case, I will show how it looked like from the perspective of BI developer. In this case, I am BI developer who participates on development of a data warehouse and enterprise semantic model. I will use SQL Server Visual Studio, and I will do some simple change in the model. Then I will deploy the model to the server, and then we can see how it's look like from Power BI desktop. So let's go to the Visual Studio. This is the Visual Studio where I have source code of the enterprise semantic model. You can see the data in the tables which are included in the model, but you can see also relations between the tables, and you can change the relation. You can add new measures here, and so on and so on. In my case, I will just add one simple measure. So I will switch to the table, and we can create, here you can see that here are some measures, and you can see the expressions in DAX language. Here is some simple, we are just summing one column, but you can use also some time intelligence functions like calculation of total year to date for the sales, changes between current and previous year, calculation which returns sales from previous year, and so on and so on. So this is how it looks like. I will just add one simple new measure, and it will be called number of customers we will use this distinct count, and we are in fact sale customer key. Okay. It seems that in total we have 403 customers. What we can do, we can also change the format, so we can change it to the whole number, and we can say that it wants to apply 1,000 operators. I can do it only once in the model, and then it's used by the Power BI desktop in all reports created over this model. So I changed the model. What I should do now is deploy this change to the server. I will use the easiest way. I will just directly from Visual Studio click deploy and deploy this to the server. Deployment was very fast. You can see that it's accessed, and there was no necessary to reprocess the data because we were not changing the data, just adding some metadata. So it was very fast. Now the model is ready. And when I switch from the model to Power BI desktop and I click refresh, we should see then a measure here in this fact sale table. So where is the refresh here? And you can see it's here. So in this case, I don't know, we can change sales for the number of customers, and we can see how many customers bought something in a particular year and month. And you can see it works. So it was a very easy change of the model. And it's after deployment, it's immediately available to the business analyst who can create new reports based on this. Maybe last thing I can show is one from the external tools. In this case, I will use Dex Studio. It's here. It's one of the tools, not from the Microsoft, but from the community, which I mentioned during the presentation in the morning. And here I can connect to the model. The Tableau server is the connection straight to my server, so it's same model as you could see in the Power BI desktop. And in this case, I can write here some queries and fine-tune the performance of the queries, but I don't want to do this now. I want to show something else. This tool can also easily show some important metrics from the model. So if I click View Metrics in Advanced tab, it will show you all objects in the model. And it will show you detailed information, how big is the table, what consumed the most of the memory, what columns are in the table, how the compression looked like, which encoding was used, and so on. And if you can look at this, you can fine-tune some settings of the model, or you can see some problems. For, in my case, here is relationship integrity violation, and probably there are some transaction in a fact table with the date, which is not in the date dimension in date table here. So I can see some important things for the performance and the reliability of the motor here. So it's not only about writing DAX queries and tuning the visuals, queries from the visuals, but you can also see some statistics from the model itself. So this was my last demo. And now I will hand over to Martin Bam with the last lab. And it should be
okay. So it's time to share my screen for last time. Okay. Yeah. So we have last 20 minutes ahead, and topics for last 20 minutes are very simple. So it's Databricks and machine learning in some simple showcases, and I think it's time to move ahead. Yeah, I will show you three things. One is Azure Databricks. Second, I will show Azure Machine Learning to get some idea what's the difference between them. Databricks is from Databricks and Machine Learning is from Microsoft, both provided by Microsoft. And finally, I will show you data science virtual machine as just one of starting or entry point for any data science project, which can be used to very easy in Azure environment. Okay, here's a simple demo for 15 minutes for Azure Databricks. So you can see I've prepared my Databricks machine, so I can also add the new one. You can also find your Azure Databricks in Marketplace. So yeah, it's a demo from Marek Chmel. Here's a showcase for workspace. You can select pricing tier, standard, premium, or trial. And because premium level also includes better security. There's also some setting for networking. It's standard, as we've seen many times before. And you can see there's a Azure Databricks service called the Azure DB S01. So it's very simple. You can see the console is standard, like other service, and access is through the launcher workspace. So now we are connecting to Azure Databricks. So this is Azure Workspace, Azure Databricks Workspace. So you can see on the left side there are many there are workspaces. You can also define your new cluster here. So it's important to create some cluster for your data science tasks or execution of your data science models. So it's cluster CL01, cluster mode is standard. Runtime, we can select from different versions. So there was version 7.0 beta in that period. You can see the Spark versions, for example, Spark 2 and preview of Spark 3. But we will select Spark 2.11 and Spark 2.4.5. So this runtime supports only Python version 3. We can also check auto scaling, so it's enabled. We can select some virtual machines because we need some pool of workers. So we can select machines with also there's also, but not in this account. You can use also GPU accelerated instances. Now we disabled auto scaling, so we will use only 2 workers. And I think it's all from some standard setup. So we can try to create our new cluster because because there's also driver type, same as the worker. And there are also some advanced options to optimize setup of your calculating or calculation cluster. So you can see you can also add some initial script for mounting your for mounting a file system. So yeah, there are two types of cluster: interactive cluster. So we create interactive cluster. So it's cluster which is used for some ad hoc work with notebooks. You can also create automated clusters which can be used for some planned tasks. So you can divide, for example, your production environment with just with cluster definition and share the same code, because it's data science. It's not about some standard development process with all. Yeah, and here's a creation of notebook. I will create Python notebook, but as I mentioned before, you can use multiple languages in one notebook. And here's just a simple example. And we must wait for cluster provisioning, because now it's attached to our notebook is attached to the cluster, but cluster is still under provisioning. So we can add some data, we can upload file, or we haven't mounted the BFS. So it's yeah, it's that default file system. We can create a new table, or we can create table in notebook. So there are many options to create data sets. And here's just just a simple simple template with some demo. Okay, you can select different connectors: blob storage, Cassandra, data lake store, JDBC, Kafka, Elasticsearch, Redis. So you have many options from which you can create your new table. So here is just the example how to create Azure Data Lake Store or the table from Azure Data Lake Store with in few steps. So it's in Python. So we can see some map, some configuration, and if we can continue through it. Yeah, here you can see some examples. So we can run the cell with the script, but you need operational cluster, because without cluster you cannot do anything. So yeah, we should check it many times, because sometimes things are working a different way, especially if you want to present it to someone else. So in this case, it happened also to Marek. So he's checking everywhere, including machines and connections and everything. And everything seems to be working. So it's only about some lag in the console, because after the switch back into the notebook, cluster seems to be fully operational. So now we can send our command to our cluster. So it will create table diamonds from CSV, from some demo data sets stored at that mentioned part. So you can monitor a stage of your Spark jobs. So everything is fine and perfect. Now we can select our data. So we can select everything, select all from diamonds. So Spark jobs is running. And here is just another part of Python script. So it's I think it's Python mixed with Spark, because we must call Spark for some, and there's also switch of Delta Lake because it's format of mentioned here. So we can check again, and we can also add new cells. So I can extend my script iteratively, and we can do it concurrently with other users together. So it's a great way how to collaborate during your machine learning development, because you can work on one problem in team and very easy. And here it's just about the creation of the schedule, because we can run it and we can also define it through the cron syntax. So if you are familiar with cron, standard Linux scheduler, you can use it because this technology was derived from the processing in large clusters, and large clusters were usually built above Linux. So now we can check our cluster again. So it's running, and I think we can move a little further and create some new notebook 01 in Python, which is attached to CL01 cluster, and somehow further, because yeah. So it's just the example how to create a new notebook. And yes, you can see that it's better to continue with the original one, because we scheduled our script. We can also create some read-write with Spark. So yeah, just check again the path, create table, select data from table, write down data from the table, and yeah, it will happen. Because you can also run just not only the cell, but you can run all cells above, all cells below. And you can see that our write down is running, so it's reading data from CSV file and writing into delta daemon. And we can also drop the existing, yeah, you can view stages of jobs. So it's some simple monitoring. So you can get some graph visualization of execution, and you can also we can also recreate the table with a different source. It's not the original diamond CSV, but we will fill it with diamonds copy from delta diamonds, and we can query it again. It is just a sample of visualization. So you can easily run it again. So we will get the result in a while. It's still again about some provision of the cluster, but it's more responsive than in case of Azure Data Factory, which is more to be about large data volumes. And now you can see visualization of the result. So it was just a simple demo. So it's better with Databricks. It's better to try it than to watch, because it's about working with notebooks. You must be familiar with the syntax, so we can try some examples there, and it's better to try than see. Here's my demo about machine learning, because it's very short, but it's good to know that if you are, for example, afraid of Databricks prices, because if you perform your solution on very large Spark clusters, you can try also machine learning with little different pricing, and with little different environment, because Databricks is about notebooks, Python, and everything. But you can also use machine learning, which you can provision very easy. So there are also some possibilities, but you can see it's very simple to provision it, because you can jump directly to creation. You must wait for validation of configuration. It takes some time, because machine learning is more complex than just to create something or some kind of new web console. It's a pool of resources together So now there is some deployment because there is some deployment of some virtual machine for my machine learning, and it usually takes some times. Okay, we can continue. And this one, I think that we see it before. Okay, so provision happened. So it happened in 3 minutes in this case, but I have no long speech enough for comments. And now you can see the main console of Azure Machine Learning. So it's the same like other Azure services. So you can see that the main important page is overview. You can also upgrade your machine learning service to enterprise edition. Now I think it's general available now. And the most important things here are for monitoring, and it's about the security, also about the tagging, because you must somehow describe the environment for some pricing and cost allocation. There are also important thing here is assets. So it means you need some computing power for your machine learning models. So it's loading, and you can see I have no computing instances and compute clusters here, but I can create some compute instance for my machine learning because I need some computing power. And there are some options what I can use. So I've selected the S3 version 2. So my one is creating, and it's my workhorse for my machine learning tasks. Okay, we can now launch Machine Learning Studio. So all machine learning tools now are based on notebooks because it's the most effective way how to perform data science in technology tools, because you must be very free in things you want to do. So we must be flexible, and so we can see the same console. It's familiar console to the original one. So you can see that I have some computing instance. Here are the notebooks. So I think there are some still loading, but there's also some offer of upgrade. So you can see there's also automated machine learning in enterprise version. Here's an example about the most interesting thing about enterprise version, because it also brings you a designer, graphical designer. So if you are familiar to Machine Learning Studio, so it's just next generation, because Machine Learning Studio was somehow partially replaced by Databricks, but now Microsoft refreshed the original one solution, and that's the reason for Azure Machine Learning, which is more to be. It's more about the coding, but it's more effective in the solving machine learning tasks. You can see also some sample notebooks here, but I think it's better to because here are some notebooks for Python and for R with many examples and tutorials. So we can create some experiment, and standard it's to clone the notebook or workbook, doesn't matter. So you can see I have my notebook prepared, and you can see that the mechanism is similar to the Databricks. So there are some cells with some code. There are some components for data visualization, and I can also use it in the same way as in Databricks. Also, you can see on the left side there's still my one virtual machine still creating, because it's not only about the creation of virtual machine, but the machine must be also provisioned with all libraries and must be configured to be part of my Azure machine learning. So we must wait for a while. Yeah, here you can see the time of presentation or this demo. So it was created on the 1st of September. And yeah, here's a automated ML. So you can also use train and find the best model based on your data without writing code. So here's the documentation. So it's very intuitive. So it's how to use it and how to deploy the best model to your solution. The last important part is designer. So it's something like original machine learning studio. So we can select some new pipeline. And you can see it's a graphical way how to solve your machine learning issues. So it's the way very familiar to Azure Data Factory. So if you are familiar to Python and R, you can use, if you are familiar to Python and Spark, you can use Databricks, but if you want something more graphical and more user-friendly, with some additional advanced features, you can also use alternative Azure machine learning, which seems to be a future flagship of Azure machine learning in the future. But it's this service is relatively still fresh, still evolving, and Microsoft still adds new features. So and it's also a replacement for Machine Learning Classic or Machine Learning Studio Classic, which was based on this approach. But Azure Machine Learning is more oriented to some enterprise deployments, including IoT edges, virtual machines. So there's also support for some SDKs, and that's all. It was about graphical designer. You can also use different notebooks because it supports more than one. So now I try to open Jupyter. Okay, so it takes some time to open. Yeah, now we can see Jupyter. And you can see there are also some notebooks here. So I can create a notebook in Python 6.3.6, and there are many other parts. So it's and there's also Jupyter here. And there's also RStudio because it's a tool already bought by Microsoft many years ago. So it was considered one of the worst acquisition of Microsoft in the history, but I think it's gossip because the tool is seems to be relatively major. And now you can, for example, use your R script. So it's also your R environment, which can be used with the rest of Azure Machine Learning. So yeah, here's just our experiment. Yeah, what's is missing? It's compute, and I think there's a problem that there's a no valid compute target. So we can define a new one. Might do. And now you must wait for provisioning, so it will take some time. And save. So after some modeling of machine learning procession, we can continue We can continue. We can continue with the training model. So there is some commands, some settings. Okay. Now we should check our compute, because without compute power we cannot execute training, because there are 3 steps or just 4 steps. First is data preparation, then we split data, we train model, and then we score model, and then we evaluate model. So there are all 4 steps here. Yeah, so it was short introduction, and it's time for data science virtual machine, which is part of the environment. Okay, I think that it's better to show you as yeah, it's working. So yeah, we provisioned data science virtual machine, so I think there is no reason to show it again, how to find it in marketplace, because if you know the name, you can very easily find it. And you can connect to your data science machine through a remote desktop connection, so you can download RDP file. So here's a file for remote desktop connection, and we can easily connect to the environment. Now its password is needed. It was created during the initiation of that virtual machine. I must use different account because I've created account Martin with some very secret password for this special case. And we can continue. Okay, so we connecting, and it's on the address screen. So now, yeah, and you can see it's so it's started. So we are in, and we can check it because you can see there's a Power BI desktop installed here. There is also Visual Studio Code. There are many data science tools, including MapR. There are many drivers here. There's also, I think there's also SQL Server Management Studio here. So you can use it as a prepared data science platform, including Jupyter, which is also part of Azure Machine Learning Service. So it's open source, but you can also use it in local mode. So now we are waiting. So we must enable some plugins. And I think it's the weakest part of this machine. Missing rules. Okay, so it's about adding new sites, because the default web browser is still Microsoft Explorer. Yeah, and now after many clicks, you can see recommendation of Microsoft Edge. Yeah, and you can see some command console here. So you can also use your Azure Machine Learning here, because it's just like standard other data science machine. but this is pre-built for you, and you can easily manage tools for your data science tasks. So it was about data science machine. So it's just image for some desktop data science development. But from this time, my demos are over. So I think it's time to check Q&A sessions. So there are no open questions, answer question, dismiss question, and I think there is something in the chat. Okay, so it's about a message only about the leaving. So some final conclusion or final words, because I see no questions around. So I think that my colleagues will send some follow-up, and it's the time also that we survived another webcast, which was focused on how to perform data analytics in Azure, in the cloud. And we started with some general topics like business intelligence and data warehousing and why we need them. Then we continued with modern data warehouse in Azure and with some needed components and how they are connected and how they fit into logical architecture. What are their roles and what are, for example, types of models. And then we continued through the technical stack. We started with storages. It means blob storages. Then we continued to Synapse Analytics. It's an analytical flagship of Microsoft in Azure, or I think it's a flagship for all types of analytics. Then we mentioned, or we described, role of Azure Data Factory as an integration platform. So it's just a new serverless ETL service. Martin described us how to properly use Power BI, and finally we mentioned also something about data science and Databricks and machine learning. After lunch, we showed some technical demos, including Synapse, blob storage, how to work with files. I've showed extensive demo, or very complex, not a complex demo, but very wide demo of Azure Data Factory, showing all standard parts of Azure Data Factory except SSIS integration service from developer perspective. And finally, or the final parts, we demonstrated some abilities or features of Power BI and how to use it properly. In the final part, I described or showed Databricks and machine learning to get some feeling about how that tools looks and how you can use it if you need them, because they have very familiar standard or approach. So you can use it in many cases as complements. In some cases, you can use one or the second, and it doesn't matter. Because I think that the most crucial question is, for example, if I should use for my ad hoc analytics Synapse or Databricks, but not the question is not about if I should use Databricks or machine learning, because if we are fan of more graphical way like other Microsoft tools, you should prefer Azure Machine Learning. If you are a fan of open source based machine learning and advanced analytics based on top class open source, you should prefer Databricks. So I will check again answers. So no answers here, so it's strange. And yeah, what is in the chat? It seems to be clear. Okay, so I think that our time is over for today. We thank you all for participation, attendance in this webcast, and it will be a pleasure to meet you somehow in person. It means online or face to face in the future. So we hope that you enjoyed our webcast and you find some information which you will use in the future, and it will help you in your work or in your assignments. So thank you all, and I think we can finish our webcast for today.